already started disliking topics like basics of this, introduction to this kind of thing really, because this eventually gives you some time to settle down, okay, and be familiar with the environment while asking questions freely. Okay. So, I am again here with a topic which starts with the basics of ad hoc networks and sensor networks. I guess, I mean, many of you are aware about these kind of phrases, keywords, especially sensor networks, because these kind of networks are being talked increasingly, okay, for even day to day usage. Though by genesis, the ideas were actually initially promoted for many non-civilian applications really, but the point remains that some of the concepts of these two kinds of networks, which I want to keep separate, ad hoc networks and sensor networks, they have relevance to your theme of short range wireless communications. Not only so, there is another implicit aspect which I will not be discussing, but you will hopefully be following naturally, is that of, I mean, evolution of the cellular concepts for cell phone kind of issues really. I will just start briefly with that, because I may not be coming back to that same issue again. It is like this, that if you are in the know a little bit, you may agree that for example, in India we started with a cell phone communication system which was actually a second generation cell phone system with big towers, okay, and then each tower is supposed to cover users, telephone users, within a certain cell radius, and initially the typical cell radius used to be anywhere between 1 kilometer and 10 kilometer, and in some cases even beyond 10 kilometers. So, and those cells are largely called as macro cells, outdoor macro cells. Large areas were to be covered by a single base station. Though the cell size or the area under the coverage of one base station was not the same everywhere, depending on the anticipated traffic, that means how much volume of data is likely to be generated per day, etc. They were also important considerations, and accordingly the cell size used to be adjusted. For example, in rural areas the cell size used to be typically pretty large compared to a typical cell size in the heart of a big city. Am I making sense? Okay. The reasons were many. One of the reasons were the generation of data or traffic. Okay. If there is a high volume traffic requirement, then well, the cell size had to be made lower. But if you just think a little bit, you may feel that if there are certain natural advantages in making a big cell size. For example, to give cell phone coverage to the whole of our country, if the cell size used to be of radius 10 kilometer or so, the number of base stations would be somewhat less than the actual number of base stations that we have in our country today. Okay. With bigger cell size, fewer cells would be necessary for covering a particular geographical area, simple geometry. However, what has happened with the growth of technology and the popularity of cell phone services and many more applications being integrated, gradually across the standards of 2G to 3G, 3G to 4G and 4G to 5G, okay, what is essentially happening is that the size of the cell, the size of an average cell, if I may talk about that really, is only decreasing. Do you accept that? I mean, okay. Again, there are many reasons why when they are practically deployed the cell size is decreasing, but even otherwise also there are certain merits in decreasing or reducing the cell size. Okay. 2G cell size has been much bigger, okay. 4G cell sizes are likely to be much smaller, and for 5G people are talking already, and they are also, the ideas are already there in the market really, of various ideas, various kinds of cells, not only macro cells, micro cells to start with. Have you heard about micro cells? That means small size cells compared to the usual big size cells. The typical radius may be up to say 1 kilometer, okay, anywhere between 100 meter to 1 kilometer. Then people also talk about what are the kind of smaller cells? Pico cells, yes. Femto cells, yes. Just can you elaborate a little bit about what are those pico cells and femto cells really? There are even smaller cells. Then how big is it really in terms of cell radius, equivalent cell radius? If for example, a microcell radius is 1 kilometer, say 100 meter to 1 kilometer, then what may be the size or radius of a still smaller cells, that of say pico cell? How much? Not very difficult to imagine really. I mean, maybe a few tens of meters. Okay, fine. And for femtocell, maybe even less, which means, I mean, maybe inside a household environment or in a building, okay, one can think of multiple cells existing, at least conceptually and even operationally. I wanted to come to this point of femtocell, or if not femtocell, the picocell, okay, in the sense that in the morning while we were talking about a kind of short range communication, the idea of smaller and smaller cells are already there in the cell phone technology. Okay. So, the cell phone companies, those who are in that game really, they also have interest in reaching out to individual subscribers or users even in home conditions. Do I make sense? Then can you just imagine a situation what is likely to happen or what may happen in future, in some distant future? In one direction, because of technology development, because of many possible applications, if we accept that well, there is a need for short range communication. Okay. Then on the other hand, we find that the cell phone technology also is growing in such a manner that the cells are becoming smaller and smaller. So, try to converge these and think of yourself as a user in distant future, and then imagine what may be a very comfortable and very good situation for you as an individual user. Louder please.
Have a tower in your home.
Have a tower in your home. See, getting a tower is not a very good idea because of other kind of issues which are now being.
Functionally, what are the tower supports?
Tower means say a base station kind of thing, a central first level of infrastructure support, okay, from which connectivity can be extended beyond the line. That means towards the main network or core network or something, including in terms of applications the so called internet, isn't it? Okay. So, whether you have a tower or not really, you want to have such a central place somewhere in your house. Okay. But what about that short range communication contribution? I mean, you like all your gadgets, okay, and even certain animate objects also to get connected, okay, and you would like to get internet facility also extended everywhere in each and every corner of your house, fine. So, that even if you are not there, you can get all detailed information through a device which is compliant to internet, which has internet access really. Does it make sense? That means, it is not that a short range communication system will exist somewhere in isolation, okay, and need not the entity is there, okay, which are making this short range communication network or system. They will be communicating amongst themselves and they will not be communicating to outside world. It should not be like that basically. No small network should be left alone, at least in the civilian domain. Okay. If you think of that really, then each and every gadget should be connected to internet, isn't it? Fine. So, people are thinking of that only, that precisely, and the eventual idea, one of the major ideas behind is that all the small gadgets which are not so intelligent, semi intelligent or even not at all intelligent today really, may have some intelligence, maybe added some intelligence, so that all kinds of information of your interest will reach you as well as anybody else whom you authorize, if the information belongs to your property. Okay. So, with this there is always a need for internet access, which is not possible always these days, isn't it? If you have a computing platform, you do have. If you have a portable platform in the form of cell phone, you do have really, but many other items are left behind. So, the buzzword which is there is something IoT. Have you heard of? What is that? Internet of Things. I do not know, I am not an expert in that basically, but sometimes I wonder what are those things basically. Can devices and only devices, not necessarily communicating power you will be able to give once you go through this course and do a little bit of exercise really. Okay. So, it is not, I mean, anything, any entity which is of your interest should be able to communicate, okay, the way, I mean, following the required protocol, etcetera, so that they can get information and they can also give their own information, like that. Communication is an essential part of that for any network really, but this so called Internet of Thing is probably a very all pervasive ubiquitous network, okay, where there will be many other elements other than the usual common sense computing platforms and your smartphones and things like that, which means that the number of entities which will now be integrated with internet is going to sort of increase suddenly, almost exponentially. The number of small things which will have internet access through some means, okay, through maybe a local tower or a kind of towerless access point, because the connectivity from your home may be extended through some cords or wires as well. Wires are not bad really. Okay. So, through multiple schemes, whichever is effective and whichever is cost effective, I mean, you can have a solution, but the point is that each small entity which should get internet connection may get internet connection. That is the issue. Okay. So, in fact, for many of the discussions that you will have here, I mean, maybe focus towards that concept which is picking up very fast really of Internet of Things, IoT. Okay. Now, sensor networks that way forms a rather primitive form of IoT, where small sensors can be placed, they will sense something and they will send some information. I will come to that bit shortly, but only after we discuss a little bit about this ad hoc networks basically. Who can tell me a little bit about ad hoc network? So, can I save time and you can go through, I have included some basic material really. Okay. So, in your off time also, if you like, you can go through the material. I have deliberately put some additional material, knowing that I won't be able to cover that fully here, but to have a continuity really, I would welcome if some of you can tell me what is the basic concept of an ad hoc network. Ad hoc networks, they are important for both civilian applications as well as non-civilian, or I mean defense applications. Ad hoc network, cell phone network, cell forming networks. Tell us a little bit more about that. No infrastructure, right? That is good. On demand networks, right? Okay. Can you give me an example of that? That is good. Okay. Some network, okay, which can be formed on an ad hoc basis. Okay. I mean, even without, I say even without, okay, the support of any infrastructure system, any telecom infrastructure you may be knowing is usually costly, okay, and needs time to create. Fine. So, if you want to deploy a network which does not need any infrastructure support, then you have a good advantage as well. You can deploy the network over a very short time really. So, maybe that is one core idea really. And anywhere. Good. Why are you raising this issue of where? Just tell me a little bit. He says anywhere it can be deployed. Yes. Largely yes. Media is anywhere required.
One middleman is not required. One middle component is not required.
Central server is not required. Okay. That middleman idea actually in some sense is there here. We will see. Okay. So, it's like this, that you actually can communicate almost directly to other user, or maybe through a few neighbors, good neighbors who are equally equipped in terms of capability. That means, if you have same category devices, okay, they can form a network. You do not need a more powerful leader or some central processor or server, the names vary really, or base unit or something, I mean for operating this whole network kind of thing. That means, it is a kind of decentralized situation. Okay. There should be minimum level of agreement amongst the users and they can start communicating, and we say, well, a network exists because a network essentially consists of at least 3 or more nodes. Okay. So, this is really the essence of ad hoc network. Okay. And then, for example, in a civilian sector for disaster management, I mean ad hoc networks have been found to be very reliable in hilly areas, okay, in seashores, okay, and also in seas. I mean ad hoc networks come very handy. Okay. Now, the ideas of ad hoc network have been there. In fact, the initial ideas for like in many situations really were mooted for defense requirements, okay, but we need not worry much about them really. And in the context of ad hoc network, the issue of mobility came very soon. So that people started talking about not only ad hoc kind of network, but mobile ad hoc network or MANET in short, which means that well a group of nodes, okay, can form on an ad hoc basis just like that on the fly, okay, a network amongst themselves, while some or all of them may be moving. This mobility part is a very important feature for most of the ad hoc networks. Okay. But then this gives me an opportunity to tell you a little bit more about the differences between the word mobility and portability. Okay. Your cell phone systems are mobile systems, you can carry it, okay, and you can move, but at what speed? Some idea? The highest speed at which you can move and still can have a good cell phone communication. Can you give me an idea of that? 50-60 kilometers, isn't it? Okay, 60 kilometers per hour is a somewhat old data basically. The 2G systems were designed up to that basically, but then yes, 60-80 kilometers or even 100 kilometers, okay, per hour. Even if you move at that speed, which is not very small really, you should expect a good reliable cell phone communication. Okay. We say yes, that is a mobile kind of system, the system which works even while there is a great mobility between the transmitter and the corresponding receiver. Relative motion, that is what we are talking about. Whereas, we also have another situations where even if the mobility is not so high, but there is a kind of relative movement, smaller one. Say if the relative motion between a transmitter and the receiving station is of the order of say 3 kilometer per hour or 5 kilometer per hour, that means somebody maybe is moving probably, okay, or maybe cycling, maybe a few more 10-15 kilometers per hour. I mean, then we can see that the motion is not so great, and this motion plays a very important role in the design of cell phone communications. If that much of high mobility was not to be ensured, then the design of the cell phone communication would be much simpler. Okay. But then cell phone communication has to develop, and the systems are now developing so that they can withstand or they can offer even greater speed between the transmitter and receiver station. Even if you move in a high speed railway, okay, train, you should get full connectivity. That is the idea really, okay, and technology promises that it is doable. Whereas, in this kind of infrastructure-less system really for ad hoc network, there may be situations where that kind of great mobility is not there. Okay. Still an ad hoc network can exist, like many of you can open your laptops, okay, which supports Wi-Fi, okay, and no other central system, and still you can form a network amongst themselves, okay, sitting in a seminar room or elsewhere. So, that is a kind of ad hoc network where mobility is not the major issue. Okay. So, mobility should not be necessarily a part of ad hoc network, but yes, if there is a need for a network, ad hoc network, but the network has to be ad hoc in nature and there has to be great mobility, then the design obviously should not be as simple as that of a static kind of ad hoc network. That should be understood, which means that while you can communicate nicely using say the older versions of Wi-Fi in a seminar room, do not expect the same thing to work if there is a great motion amongst you basically. Okay, that should be clear. Now, here I mean ad hoc network has some inherent problems if there is mobility. Okay. By wireless node, I do not mean the cell phones. The cell phones as such have their mobility capability, and the cell phone system is supported by base station. Here we do not usually have base station. If there is some kind of data collection station, it is fine, it can be integrated, but it is not necessary. Now, some of the features is that to reach between a source and a destination, in this diagram, I mean suppose A is a node and D is a node. I mean A wants to send some information to D, then it is not necessary that A will transmit the signal so strong that it will reach directly D. Usually that is not done. Usually depending on the distance, the transmission power is not adjusted, because as you were discussing in the morning, if from here I have to reach somebody at certain distance, I can transmit at some power, so that the received signal is strong enough, more than the sensitivity level, etc. And if I have to transmit signal to another person who is this much away really, then one solution, obvious solution is that I transmit with a higher power, okay, so that I directly reach a distant person also. Now, this approach is normally avoided in design of today's wireless communication systems. Increasing power is the last option now, okay, in digital communication systems, and transmit power should be increased only when there is absolutely no other option. Okay. The trick that is played in ad hoc network is a bit explanatory here. As you can see, really these arrows indicate that if A has to send something to D, A does not try sending it to D directly when D is at a far distance. Okay. Instead, what is decided is that each of these node as if has got some kind of range of coverage. These big circles, they indicate the radio range of coverage of a node. Now, this again is something conceptual. Truly speaking, there is no such definite line. Okay. I mean, if A transmits at its specified transmission power, then usually the signal is well received in this region. That is the idea. Okay. If somebody is just here, just outside, that entity also will receive some signal, may not be as good. That is the idea. Radio signal does not decay just like that, it decays only exponentially and gradually. Okay. And the idea is that, well, A transmits at its designated power level, and then D does not hear it, because D's radio range is here. That means, D can also receive signal if it is from somebody who is within this range. So, if A transmits something which is meant for D, at least as per this diagram, I mean, the signal does not reach D just like that, and so you bring in the idea of intermediate nodes called repeaters, isn't it? This idea of repeater again is a very old idea. Okay. And the idea here is that if there are other nodes such as B and C, and then A can, the message of A or the data packet or whatever name you call give of A will reach D when A transmits and B is ready to receive it. Okay. And then B knows that, well, this is not meant for him, it is meant for somebody else, then B again sends it usually in an omnidirectional manner. Okay. And then instead of reaching D directly, it reaches C, and then C, when it finds that, well, it is again not meant for it, okay, it tries to broadcast, and then eventually it receives D, it reaches D over there. A few basic features are clear here. One is that the commodity that is normally exchanged in such an ad hoc network is not speech kind of signal, is not speech kind of signal. Can you tell me? I mean, following the procedure that I explained, it is not a very good scheme to send speech signal or voice signal. Why? Delay, order between if order means the packets, the speech signal usually will be packetized and several packets will be transmitted. Okay. The packet should be received in the same order at the receiving end. That order should be maintained, otherwise the meaning will get lost, isn't it? And this is an old problem for digitized speech signal. Okay. And this problem is old because, I mean, it has been there for ages for in satellite communication systems, digital satellite communication systems, and there are solutions. Okay. You can sequence the packets, you can put a tag, and so that the ordering is not a problem at the receiving end or the destination end. Yes, but ordering should be maintained for speech signal. Speech is a real time signal, isn't it? I mean, if you are really in a communication mode with somebody, as I was telling you in the morning, that communication means both way communication, and speech is such a commodity. If I say something, I need some response, and if I do not get the response quickly, my next speech might be different really. My next speech sample or speech segment is dependent on the response that I get. Okay. So, it is very important that my speech signal in pieces should be taken fast and the response should be brought back as soon as possible. It is not possible to ensure that in this kind of arrangement. Okay. So, this kind of arrangement in general is not good for speech or real time applications. For non real time applications such as data, any data etc. Okay. If you want to transmit, well, this procedure makes sense. Okay. This had some advantages in the sense that a particular node need not transmit at a very high power and try to reach directly the other person. That creates a lot of problems. What kind of problems can you guess? If instead of this approach, we allow a node to transmit with the desired higher level of power to reach directly D, which is the worst thing really. But if you still suggest that, I mean, I said no, that will have a big problem. Can you guess what is that problem? Pardon? Power amplifier capacity should be good, so that it can handle higher transmission power, okay, which means most of the times the cost is going to be high. That is one thing, but there is another big casualty. Two things may be transmitted at the same time, that may happen if somebody else also tries the same thing, okay. But there is another inherent issue which is not very clear, is that of the power source. See, these are all computing platforms or data generating units, okay. They are not necessarily tagged to the main grid power, okay. So, they may move, okay. So, usually they will carry a battery with some capacity. So, if the transmitter transmits sometimes at a very high power, the battery gets exhausted, okay. So, that is another big reason why they should not transmit at an unnecessarily high power. So, power transmission must be limited to the lowest possible value, okay. Though there is always a provision to adjust it to a few allowed levels. It is not that a unique, the same power is always to be transmitted, it is not that way as well really. Now, sorry, okay. Now, this idea then is good for data communication or non real time communication, okay. And this can be fine only if B and C they agree to take the packet that is received from A. Note that B and C, they are intermediate nodes, and what do they have by taking some packet from A and delivering it to D? Do they gain anyway? What is their gain? No, okay, because their devices, if you make them, design them, they will work, but amongst human beings, do we behave that way? Not necessarily always really, okay, fine. So, here is an essence of cooperation, okay. It is a kind of cooperative environment, where these nodes or all participating nodes must cooperate, at least they should agree to follow certain things. And there is a great advantage, okay, that if today A, B carries A's packets, okay, when there will be some packets originated somewhere else meant for B, B also becomes sure that, well, it will hopefully receive the packets, okay, through other intermediate repeaters. Okay. So, this certain or limited amount of cooperation has to be there. Okay. Now, based on these premises, I mean, there may be some practical issues as well, okay. One or two I will name over there, but the point is that, I mean, this is the general way. All these nodes, they should be equally capable. There is no need for any extra node, more powerful node bringing in discipline or dictating, etc., etc. Okay. And if you again just think a little bit about the possible mobility, there may be one situation such that this particular route from A to D, that is from A to B, B to C, C to D, may not exist after some time. Okay. Maybe for the present packet from A to D, this was the path that was used, okay, but after some time, because of mobility, many things may change really, and from a packet from A to D may reach through some other path, if some other repeaters are there, not necessarily B and C at the same locations. What does that mean in terms of routing? I know you are all, yes, yes. Route table should be present, okay. So, each node should have certain additional features. Each node should behave as a router first of all. In fact, we use the word router more frequently in this context of ad hoc network than simple repeater. Repeater is an older word in radio technology, okay. We call these intermediate nodes as routers, behaving as routers, and then each router or each intermediate point, or for that matter every node, participating node, maintains a table of present level of connectivity. Who are the neighbors at this point of time? Okay. This is another essential point when it comes to designing the routing table for each of these devices. Okay. Now, this we have discussed more or less. Okay. So, routing is an important issue, unless we say that well the whole network is static, no, there is no change of, and all the nodes are always on, always connected. Typical applications: emergency operations, search rescue, and this personal area networking. Okay. See, under personal area networking, I mean the idea is that an ad hoc network can be formed, okay, using these kind of gadgets. I do not know whether you believe me or not really, but you are already hearing cell phones are already having internet access, and Wi-Fi is included in the cell phone. It was not there, okay, earlier. The laptop is always included, wristwatch they are also coming. In civilian environments we have discussed, education is a big area for application of ad hoc networks, and some sensor networks in a limited sense. Well, some of the challenges they are just listed here. The limited wireless transmission range is by design, because we would like to save battery energy, that is the limited thing, okay, and the cost also should be very small. By the way, have you seen the size of the card or the ICs there which are nowadays used for providing this kind of Wi-Fi connectivity? Have you seen physically how big is that electronics which provides you Wi-Fi connectivity? Sorry, a bit unrelated, but just thought of, because sometimes the size gives you an indication about the power level it can handle and cost and other things. 10 centimeter by 10 centimeter, okay, that is quite on a higher side, used to be there earlier, okay, but now Wi-Fi capability is integrated in your cell phone in some, okay, 3G 4G cell phone, they are already integrated. So, it must be within that, okay. Your computer, I mean laptop, most of them had Wi-Fi connectivity. So, basically a few ICs, okay, and then the size has reduced, and the overall power handling capability also is not much. Initially it used to be up to a few watt, but now is again much less, as I was mentioning in the morning really. So, transmission range is limited to reduce the power level. Then because of wireless transmission, which is usually in the all direction, omnidirectional in the broadcast mode, I mean there is a problem of hidden terminal and exposed terminal problems. I hope there is a diagram which explains these basic things. Packet losses due to transmission errors. This is something I have not talked about, but can anybody tell me what I mean by this? There may be packet losses which may happen. Okay, there are some uncertainties regarding the performance, end-to-end performance in such a network really. Packet losses due to transmission errors. This may happen, okay, in an ad hoc network, simply because of, there are many reasons, but one important reason is that the relative locations, if they are changing, if they are moving with that, the distance is increasing, okay, and the transmit power remaining the same, the quality of the received signal goes down really, and at some point of time you find that the packet is not acceptable. Incidentally, I mean packet error and is detected in the in which layer? Are you familiar with the layered protocol architecture? Network layer, not at the network layer really. Say if I remember, for example, the standard ISO OSI 7 layer model, if you think about, the bottom layer is the physical layer. In fact, most of our discussions here is on the physical layer, and then you talk about the MAC layer, network layer kind of thing. Whether a packet is received error free or not is checked at the MAC layer basically. Okay. Now, the physical layer, if the physical layer degrades, the distance increases, okay, then the packet is received with some errors. If the physical layer cannot take care of that through error control coding, and then if the packet is delivered to the MAC receiver MAC layer really, then the receiver MAC layer rejects that. If there is error, the packet has to be retransmitted. Okay. So, this kind of situation is present here, and packet loss may increase suddenly, maybe because of mobility, or maybe because some node has gone out of the coverage area and all such things. And then mobility induced route changes, mobility induced packet losses, these are the issues very specifically relating to mobility. If things were static, these problems would be less. Battery constraint, then ease of this is another subtle issue which is now drawing a lot of attention these days really. There are security. For any wireless communication system, security is becoming a big issue, and similarly for ad hoc network. Okay. For non-civilian applications, this is a very important aspect really. Well, this is the overall architecture in terms of the layers. So, does it make some sense the ad hoc network architecture primarily relates to these bottom 3 layers, the physical layer, data link or MAC layer, and the network layer. So, this is if this is a source node and this is a destination node, the point is that something, some packet or something, data packet, not usually non real time things, ultimately reach the application layer for the destination one through the 3 layer lower layers of the intermediate node, which means all such devices or nodes should have at least these 3 layers, physical layer, data link layer or network layer, is not it? And all these 3 layers have to take part in successful implementation and operation of an ad hoc network. Okay. In fact, just for the sake of imagination, okay, in order to come up with new systems, new things, etc., you may imagine whether you could come up with a radio network system just by using the last 2 layers, for example, not involving the network layer. It's a good exercise. Okay. Or for that matter, for the traditional systems, basically the entities would communicate only at the physical layer. This is the commonest example. The radio systems, they integrate at the physical layer, okay, and the upper layers are immaterial. They may be different for different purposes. With more development in technology, okay, and VLSI technology is a very important contributor here. I mean, it is now being possible to integrate the layers, higher layers such as medium access control and network layer or routing layer, okay, and come up with a easy to use, very convenient, versatile radio equipment. So, radio transmission reception is no more the only thing, okay. It is that how, I mean, when to use the radio resource, the frequency band, okay, at which power, and then how to route the packets from the source to the destination. All these issues are also getting integrated, which indicates that there has been a change in the design approach of these newer radio devices. You may verify while you are examining any system, really, be it a cell phone or this kind of ad hoc networking elements or systems. These layered architecture initially said that, well, you think of peer levels only, the same level, okay, and design the corresponding, focus on the corresponding layer, design protocols for them, okay. And then the experts in this data link layer, for example, to start with this physical layer, the physical layer algorithms, etc., they were the business of communication guys, okay, who hardly had to bother about this kind of data link or multiple access, medium access issues or the routing issues. And routing was a different ball game, okay. Router means to many of us even now a kind of huge computing device, okay, with lot many memories, etc., etc., and router design is a great job, you know, only a few companies in the world do, like Cisco, Juniper, etc., etc. But my suggestion is that please think that we are also talking about designing some routing protocol as is necessary in a small radio device and calling it as an ad hoc node, which means that it is not that a particular design approach has remained stagnant over decades. It is not, many things are happening, okay. In fact, now is the age of cross layer design. You imagine a system, you define the functionalities, okay, list out the corresponding protocols that you may need, even across, cutting through the layers over there, and think of their efficient implementation, come up with the apps and in a cost effective manner. Maybe you have a new market altogether, really. So, cross layer design approach is in, okay. It is no more, if you are an old timer, if you really like layer by layer design only, I mean, compared to that, now is the age of cross layer designing over there. So, this ad hoc network is probably one example where simple, I mean, straight away cross layer design solution should, I mean, works. No, not at all. See, the point is that, see, here in an ad hoc network, the compatibility that is needed is to another identical device, isn't it? See, an ad hoc node has to, yeah, on to a similar node, that is it, okay. So, beyond this network layer, well, compatibility is not necessary, I mean, they may be of different one, okay, but these layers are all integrated inside the same device. Well, a little bit more on the physical layer. I mean, this is the starting standard IEEE 802. I think Madam Devarati is going to speak more on that, but my idea here is to tell you that, well, this has become very popular, isn't it? WLAN standard it has got many other variations which are not included. The only thing to be noted is that the various parts of the standard, they are focused on various aspects really. Okay. And security is a very important issue, it is still being researched. Okay. Lot has been done, and they are still under development. On medium access control for ad hoc networks, the medium access control is necessary. I will just try to summarize the need for medium access control. As I was telling you in the morning really, I mean each node may have a good capability, but when it comes to sharing the same frequency band with many other users, there has to be some discipline. Okay. One discipline is that whenever I have to transmit, I transmit, okay, and then whenever somebody else has to transmit, the other, he or she transmits over there. Okay, so that everybody shares to using the same frequency band. There is a common problem in this. You can guess what is that. If there are say 25 users and there is only one frequency band which is given to all of them, they have to share a particular frequency band that is given, and there are 25 users. How do they use it? Is a very basic problem. One way is to do that, well, I mean there's somebody has to tell, or there has to be some plan, so that over a time frame of say 1 second, user number 1 uses it for 10 millisecond, user number 2 uses for another 10 millisecond only after first user has finished, and in such a disciplined manner eventually all the users will use the same frequency band, but at different points of time. Does it make sense? Okay. This is a very basic kind of, I mean resource access strategy or medium access strategy, but I say this is very basic and very old one. Can anybody support me? Yes. This is called as what scheme? This is known as TDMA, time division multiple access. Multiple accessing of what? Radio resource. Okay. But then it is on a time division basis. Okay. This is not good for all situations, okay, especially for this kind of ad hoc situations. Can you just tell me some other schemes of how to do this really? CDMA, that is code division multiple access. Okay. How is that? How is that? Use some codes, everybody uses codes, but the good thing is that all of them, okay, transmit simultaneously at the same point of time, no time staggering. Okay. They may transmit at the same instant, okay, using the same frequency band, still one can get back its own data by using that code. Okay. This also has some limitation in the sense that the interference does increase with more and more users over there, and that sets the limit, but still it is a good scheme. In fact, people say it is already shown that well, the CDMA seems to be more efficient in terms of utilizing a frequency band compared to TDMA. Okay. There was another basic scheme which we do not talk much really nowadays, that is FDMA, frequency division. Whatever frequency band is given, you allocate it to the users and let them use as long as they want, kind of thing. Okay. But these are all a kind of scheduled multiple access arrangements, where some discipline has to be brought in right at the beginning and everybody has to follow that. Okay. Now, following this in ad hoc kind of network is not necessarily the efficient one. Can somebody guess some other kind of mechanism? OFDMA, OFDM. Well, OFDM is a bit very important concept, OFDM, isn't it? CSMA, frequency division duplexing, right. Well, frequency division duplexing is mainly at the RF level, okay, and that is for in fact the usual communication, unless we talk in detail about that, is assumed to be frequency division duplexed basically. Okay, where one frequency band is used for communication from this end to the other end, another frequency band is dedicated for communication from this end to the other end, and both of them can communicate simultaneously, kind of thing. Okay, and this is though it allocates the frequency band in an inefficient way really, but it is better for long distance communications compared to the other one which is known as time division duplexing, TDD kind of thing, which is okay for short distance communication. In fact, for this WLAN, when it comes to implementation really, usually this TDD mode is preferred for a shorter distance. For longer distance, again FDD is preferred, but this is of accessing the radio resource amongst many users, where the overall efficiency matters. Okay. Assume that each entity has been designed based on TDD or FDD. Okay. Now, what we are talking about is when there are many such users, how their overall usage is maximized or at least quite impressive over there. And there are many uncertainties as well. For example, if you know that okay, there are only 10 users and only they are going to use, they only have got traffic and they are going to communicate amongst themselves, the problem is much simpler. Where you do not know the actual number of users, then what do you do? If it so happens that some users are only they have to transmit more things than some other users, then what do we do? And there are finer issues. I will just name so that you remember. You all know these basics, I guess. Really, is that well, there may be situation that some users, they have a tendency to get more resources for themselves, so that they can communicate more and more, while in the process some users who may not have that kind of requirement may get deprived as well, some kind of unfairness or something. Fairness is an issue. Now, the basic thing is that if the whole situation is very predictable, there is no uncertainty, number of users, their usage, etc., then this kind of FDMA, TDMA or CDMA makes sense. Okay. Whereas, in this kind of network, okay, small wireless networks or ad hoc networks, that does not happen, and hence a kind of random access strategy is necessary. Okay. Like he mentioned some CSMA. What is that? Carrier sense multiple access, isn't it? That is another form of multiple access, which was not there, which were not there in the traditional telecom system, okay, but has been there in data networks for a long time. CSMA CD collision detection is a very popular age old technique in computer networks, isn't it? Connect to computers or several computers through wires, UTP cables. Okay, CSMA CD is there as a default one. In wireless, CSMA CA. Okay. So, CSMA CA is one such algorithm which is good, which goes for carrier sense multiple access, okay, avoiding collision. What do you mean by collision? Collision of packets, okay. In a wired communication network or computer network, if certain computers are connected through wire, then they have got some electronics where if some computer generates a packet and launches a packet, okay, and simultaneously another computer also launches a packet, both of which arrive at a particular computer, then the two packets they collide basically in time, which means that okay, suddenly there is an energy burst and the receiving computer does not receive any of the packets clearly, okay, but then it is detected that well, collision has taken place. In wireless situation, that kind of collision cannot be detected. Collision of two packets in the air cannot be detected by a receiver. Okay. There are many reasons. One fundamental reason is that the receiver does not know that there was a packet meant for him or her, okay, and such issues. So, the carrier sense multiple access avoiding collision is one strategy which is quite popular really. Now, here what I have done is that I have just summarized, it is a kind of small classification table, in fact, for 2-3 layers only, where we are talking about two different kind of medium access control protocols. One is a distributed type, the other one is centralized type. Can you guess what I mean by distributed type distributed type medium access control protocol? That means the medium access control is not dictated or monitored or supervised by any central station. Okay. It is inbuilt in all the entities, okay, and together it works. Whereas, in a central one it is not like that. Okay. Now, the central one conceptually does better in some cases, okay, but not always. In fact, if you have an base station or access point etc., they are okay usually, whereas random access of distributed type or centralized type, they are in general preferred and they are used in ad hoc kind of networks. That means, how to use the frequency band which is to be shared amongst other, okay, is distributed done following some random access strategy, which may be implemented in a distributed fashion or may be implemented in a centralized fashion. Okay. This up to this there are many varieties under each of these, which I may not be showing actually. Can you just tell me if any of you have gone into a bit detail about this WLAN protocol really, whether it follows this basic classification. Yes, there is one function called DCF, distributed coordination function. Okay, and DCF, I mean that means this branch basically. Okay, and this option of WLAN is already there, really can be invoked for designing an ad hoc network. That is the message. Okay, you will find some names here. CSMA, I will skip some of these. Hidden terminal, I mean exposed terminal problems are known. Some routing protocols, again there are many routing protocols. I will just be brief here. A table, a summary table which may be extended a little bit, because this table is a bit old, about 7-8 years old really, but broadly speaking, the routing protocols, routing essentially means if you have received a packet, okay, originated from some node and you are acting as a repeater, okay, you have some responsibility so that the packet should reach the destination. Both the source and destination addresses or IDs are marked in the packet that has been received. Okay, how to do that is the issue. Okay. Now, while doing that, a few things should be avoided. That unnecessary radio transmission should be avoided, okay, and unnecessary dissipation of power, okay, that means drainage of battery should be avoided, and minimum number of repeaters should be involved while sending the packet to the destination. Okay. All this should be done while there may be motions, some members may move out, some members may come in. That makes the situation a bit difficult really. Now, given this background really, I mean this unicasting means that, well, the packets are meant for one node through addresses, though the wireless radio transmission will be in all directions unless we use directive antenna, but the packet will have one address which particular, and that particular node will actually strip the packet down. I may be a bit confusing, but let me try to repeat slowly. What we are talking about is a kind of address of a source, address of a destination, and address of the intermediate repeaters as well, they also will come into picture. But note that these addresses are basically groups of bits, ones and zeros, fine. And then we are talking about radio communication, and any signal, any group of bits and bytes, they are first of all converted from bits to some kind of signal, modulated signal level, and then amplified in power, and then translated in frequency, and then transmitted in the radio frequency zone. Okay. These routers in the, or the ad hoc node elements, they have the capability of demodulating the signal back to these bits and bytes, then read the bits and bytes, find out who is the destination, okay, address, and then should also change the address of the next repeater, fine, and that means operate at the bit level in the address portion, should not look into the message portion, okay, because message is meant for somebody else, and then again go for modulation, amplification and transmission at certain frequencies. So, there is essentially an RF level, IF level, RF means radio frequency, or IF or intermediate frequency level operations, and at the baseband level operations. Okay. Finding address and then using the address etcetera is at the baseband level, whereas radio frequency that is allocated is at the radio at the RF level. So, these nodes will always get the signals at the baseband level, do the addressing overall operation, okay, reinsertion, exclusion of addresses, and then will again repackage, and the whole packet will be sent. Fine. Now, with this unicasting means that, well, the packets are meant for only one destination, while the radio signal goes usually in all directions. Does it make sense? Differently from wired medium. In a wired medium, I mean the signal goes only to the connected end, other end of the wire, something like that. There is a possibility of multicasting as well, where a packet may be meant for multiple nodes or users. Okay. So, that is known as multicast routing protocols. What I am talking about is a unicast routing protocols, where the destination address is a single address. The destination address could be multiple, and then the protocols should be designed a bit differently. However, most of the routing work is based on unicasting only. So, I am showing you the summary of the unicast routing protocols here. The protocols are usually of two types, proactive and reactive. Who can tell me what is a proactive routing protocol?
Even though there is no message to be transmitted. You Even before the actual demand is there, the routing table is always kept updated.
That means every node is alive, okay, every node is monitoring who are there in his neighborhood, and accordingly it keeps it's updating its own routing table. Okay. Why? If there is a packet, okay, which it has to repeat, it has to send again to for somebody else, it can do it fast. That is the idea. Good, very good. Okay. But can you tell me some apparent disadvantage of this proactive protocols?
They have to exchange the tables periodically. They have to exchange the neighbor list periodically, so that they will update.
Table need not be exchanged probably, okay, at least you have to know who are there in your neighborhood. That means you have to get this information, collect this information and update the table. Okay. Every node updates its table, neighborhood table kind of thing. Fine. The table need not be swapped, very occasionally that is necessary. If I know who are in my neighborhood and then I am expected to receive a packet from one of my neighbors only, okay, and then I have to deliver it to my another immediate neighbor who is best placed to send it to the destination. That is routing. Fine. Towards that, my point is that this kind of proactive behavior is not all good. Yes. Okay. You are continuously doing that, but you may not be acting as a repeater. There may not be any need for you to act as a repeater basically, but by this proactive process you are unknowingly consuming your own battery energy. So, proactive protocol, though seems to be smart really, is not so much favored. Okay. Rather than that, this reactive approach is favored. What is this reactive one? It says that only when there is a need, take actions. What is the penalty for that? So, the node acts, the node goes for the routing operation only when it is necessary, only when it is presented, or only when there is a signal that well a packet is to come. There may be a kind of delay, okay, but then otherwise at least in terms of saving of energy this is better. So, if you go through the literature you will find that there has been more emphasis on this reactive protocols and there are many over there. I will skip. Okay. Some interesting issues, well, scalability is an issue in the ad hoc network. As I was telling you, the size of the network, the number of nodes which are participating, I mean sometimes may be small, sometimes may grow, and then the efficiency of whatever protocol you are using may go down if suddenly the size of the network grows really. Then there are challenges in each of these issues of MAC protocol or routing protocol, whether the protocols are scale proof, irrespective of the size of the network, whether the protocol does the best is a perennial question really. And to my knowledge, I mean it has not yet been developed really, and hence you will find that well even now people are working on better and better protocol for in certain aspect it is better, more power efficient, etc., and then eventually it can manage a wide range of size of this whole ad hoc network. Security is an issue, I am just mentioning, I am not describing it because I am not an expert, but this is an important area even for research. Well, on sensor network I will summarize that there is a lot of similarity with ad hoc network. That is the reason I thought I will start with ad hoc networking. Ad hoc networks and sensor networks sometimes are confused. Okay. I will be happy if one of you can tell me, given this discussion on the ad hoc network, I mean what then is a sensor network? Well, I try to find. Ad hoc networks are some computers, okay, portable devices which can form a network amongst them following some medium access control protocol and some routing protocol. Okay, and they should be aware about the energy because they draw their energy for transmission or all this processing from a battery. Okay, so, energy efficient networking which can be formed within a very small time, okay, which can be disintegrated also in very small time, and it does the job of non real time data communication both way. It is a communication example. That is a summary of an ad hoc network. Okay. Given that, how do you think is a sensor network may be different? There is some definition, okay, about the sensor network here, but I will be happy if you give me some of your own ideas if you have something really. That may be a good point for me to start. Truly speaking, this ad hoc network is an example of a communication network, both way transmission reception of packets are possible. Okay. Whereas, a sensor network to that extent is not a good example of a communication system. As the name suggests, this is a bit archaic name really. I mean, it is they are being used because it started that way really. The idea, as is noted here, is that small sensors will be spread in some area, geographical area of interest, and some signal, okay, small, I mean some changes, very slow changes of time will be detected by the sensors, like change in temperature, light and other conditions, and the same information will be collected at some point. That was one of the initial ideas, and that collection point may be a static point, okay, or even maybe a moving object like an airplane. Okay. While it is going over the deployment of such sensor networks, it will keep on getting the signals, and then it will go away and then analyze the signal, etc., in an offline basis. So, the basic idea was that it was probably a one way signal transmission kind of system design, okay. But many needs have been listed already, and I will just see, I mean, these are some features of the sensor network, the micro sensors. Can you just give me some examples of sensors basically? And as you may have seen, sensors, some electronic elements with some transducers, some elements such that it will sense some physical parameter, if I may say so, isn't it? Like this microphone is also an example of a sensor. Okay. It is picking up some acoustic signal, fine, though this any acoustic signal has a bandwidth, typically spanning up to 20 kilohertz, 20 hertz to 20 kilohertz speech signal, okay, I mean voice signal, or a bit less, okay, some 300 hertz to 3.4 kilohertz. The point is that most of the sensors that were thought initially, they had a bandwidth even much smaller than this. Acoustic sensor should have a bandwidth of a few kilohertz, whereas a light temperature sensor, for example, is it not that the temperature changes rather slowly with time, and hence temperature signal, if you observe on an oscilloscope or otherwise, you will find that the temperature profile changes very slowly over time, which means that the temperature variation as a signal has a very low bandwidth, very small bandwidth. Similarly, pressure variation, intensity variation, or most of the physical parameters, they change very slowly with time, which means that the corresponding bandwidth of these signals which are being sensed is very small, a few hertz, a few tens of hertz, at the most a few hundreds of hertz, usually sufficient. This bandwidth of the signal is a very important issue to start with really, because once you know the bandwidth of the signal to be picked up, okay, you know what should be the sampling rate for the signal. Okay. Typical sampling rate then is very small for these sensors, and hence after you digitize, represent this signal in bits and bytes, the bit rate that is necessary to represent this kind of signal variation also is very low or high, low, very low. For example, if you think of monitoring the temperature variation in this room, okay, what may be the equivalent bit rate at which you should read this temperature? If you have not calculated, imagine a situation, and even if you assume that you are continuously getting the signal, okay, and then try to represent, find out the sampling rate, and then find out the bit rate, at the rate at which the bits will be coming. The bits will carry information about temperature there. The rate of bit is very small, only a few hundreds of bits per second, that is good enough. Like for speech signal, okay, for very good quality 64 kilobits is fine, okay, or 32 kilobits, and it can be even reduced with some more processing there. So, my point is that for most of the signals that are of interest for sensing, they are very low frequency or low bandwidth signals, and hence their equivalent bits is also very small, and hence if I think about a network of such sensors, okay, the bit rate that is involved is very small. In fact, this may be much smaller compared to the bit transaction rate in an ad hoc network. Okay. And the bit rate is a very important parameter, because once you know the bit rate, desired bit rate, all your design approaches may be different. Usually designing a high bit rate system turns out to be difficult in terms of cost or otherwise. Okay. Designing a low bit rate system is not so difficult. technology is available. So, most of the signals of initial interest, they were of very small bit rate. There is another relationship. If I have to pick up such signal, ultimately which can be represented by small number of bits, I can design a system which will operate at with a much lower power as well. Okay. That means this energy, just a minute, this low bit rate systems can be designed using very low power budget, and the overall requirement is that the power budget for sensor network is very stringent. Small nodes are to be deployed, small nodes will have smaller batteries, they will be drained sooner unless they are used properly. That is the basic motive. And this is a typical, a bit old diagram, really old in the sense that do not accept these values just like that. Okay, these I will just briefly explain this before I stop, because some of these may come in some different form really. Typically a sensor node, okay, may consist of these kind of blocks, like there will be some memory to store some values locally, then there will be some kind of processor. You are familiar with some embedded processors or some digital signal processors. Okay. So, a small processor should also be a part of a sensor node. There should be a battery, okay, which has a limited lifetime, and this processor, for example, it was about 10 years old now really, had 8-bit, it was an 8-bit processor with 10 megahertz crystal clock. Okay. Now, we can expect all these to be much higher really, it is possible, and then there should be radio transmitter receiver. The typical bit rate for transmission was of the order of 1 kilobits per second to 1 megabits per second. In general, the thumb rule is that if the bit rate of transmission has to be higher, the covered distance is usually lower. Okay. If the bit rate requirement is smaller, the covered distance may be larger, or you can transmit at a much lower power, they are tradable. Okay. And the typical distance of coverage used to be 3 meter to 300 meter. Okay. And then with this kind of blocks, it is possible to design a kind of sensor node. There are issues again of access control, medium access control and routing. The procedures are quite analogous, quite similar to that of ad hoc network. That is the reason I mentioned about those there in the context of ad hoc network, but they are to be tweaked as per the requirement of the sensor network, where an overriding requirement is that of very stringent energy budgeting. That is a driving point. These are some pictorial representations of some nodes. I think mica mode, many of you have heard of really. In fact, such nodes are available, I mean one can purchase also, and the nodes, these are older now, they are just to show really. The newer nodes are of different shapes. Let me add one thing, is that I mean, lot of changes have taken place. Initial ideas were to send some ambient parameters. Present practice, I mean trend is to capture images, image sensors, that means cameras, okay, and even video signals. And this is a big issue. If sensing temperature, pressure or some variation is one kind of job, but taking image or video on certain number of frames per second, 15 frames per second or so, and then sending all the pixels, picture elements to a distant place is a different ball game altogether. Okay. The general strategy is that little amount of processing is done at the sensor node, and some more processing is shared with other nodes, and eventually the summary of the changes in the video scene, okay, is only communicated at the central place or the data gathering platform. And this is bringing in lot of changes in the hardware, improvement in the hardware of the sensor net nodes, and many things are happening, and they are happening also because I said there is now an overriding need for connecting these sensors to internet. Okay. So, there are certain parameters listed here which should be sensed. You can add this, for example, this biological signal itself is a domain. Okay. It is not only sensing how my freeze is doing, okay. You may also think of sensing whether the micro motor that has been inserted in an elder's arm today for injecting some some what is it, insulin or something, okay. How is that doing? If you want to know from your office, really should be possible. Okay. So, many biological signals are now being talked about, which again will be integrated through the sensor nodes and networks eventually in the form of IoT. Okay. Preserve energy, sensor nodes. Okay. some qualitative differences are noted between the ad hoc networks and the wireless sensor networks. Okay. I mean, some wireless sensor network can take the role of an ad hoc network, but ad hoc network purposes are much different compared to the sensor network. Well, I will stop here, not much. Well, let me stop here. There are a few more. I mean, if you are interested, you can go through that really. Like sensor networks have uses in home, in office, okay, in monitoring vegetation, in agricultural farms, in forests. Weather monitoring is a very important issue. Okay, all these are, I mean, very non-civilian civilian applications. Okay, there are many defense applications as well. Really, under biomedical, a few are noted over here. This is an area which is seeing lot of changes of late. Okay. Then in traffic control, habitat monitoring, ecosystem monitoring, the list is endless practically. So, I should not try to cover all of them. It is up to your imagination. Okay. Only thing is that if you assess the boundary conditions in terms of the resources, battery, bandwidth, okay, and the quality at which you have to serve over there. I mean, newer and newer sensor networks should be designed, and I do not foresee any unique form of sensor network which is going to be designed which will serve the purpose really. Assessing the purpose, one can design varieties of sensor networks, and the field is very interesting really. Lot many problems are coming up in this area, especially when this kind of network ideas are to be integrated in IoT. IoT again is coming up in a big way. Standardization is not yet over. People are working on that. So, if you are looking for some research topics, IoT, sensor network, and of course, the millimeter wave communication systems, they are very rich areas for finding new research as well. Any questions, please? Okay. Thank you very much. Okay.
আপনাদের এই সিস্টেমটার কিছু একটা করুন,
কোনটা
এই সিস্টেমটা
কি করবো হাতে হয় না
খুব একটা
জানি ম্যাডাম
ভদ্রস্থ সিস্টেম নাই
আর নাহলে যে জন্য বসলেই এর বেস্ট যেটা এখানে থাকতো বসে পড়ালে আপনার জন্য ইজি হতো এই ব্যাপারটাতে
আপনি আপাতত ওটাকে টে করে দিন।
আপনি এখানে বসে একটু দেখিয়ে দিন তারপরে পড়ানোর সময়
হ্যাঁ হ্যাঁ ফাইন,
পিপিটিটা তুলে
ওকে। So may I have your attention please? Canteen room is specially designed, and food items, any kind of food items and water bottles, they are really not allowed inside. That's why I know that in the first half there was not that much complete arrangement of the stuff, so we allowed you people, but from the second half onwards we will request you to please go outside for drinking water, and please don't bring the bottles inside from morning, tomorrow morning onwards, okay. And actually before starting the session of mine, let me first show you the distribution of the sessionals and the groups that we have formed, and according to this group you guys will be guided in the MSPC network as well as the project lab to do the sessionals. The sessional keys are all the instructions for the sessionals are provided inside your registration kit, and how actually what the plan is, what we will be doing inside, how will you be getting used with the software and all, that will be gradually guided slowly, okay. I have kept a special session of 1 hour before the sessional is starting on Wednesday after lunch, so there the detailed instruction will be given, and as you are seeing that one instructor per 2 candidate basis, that's the allotment is. So we are having 25, a group of 25 instructors here who are basically the PhD students, postdocs, and as well as the few of our MS research students who are well trained on the software, who will be guiding you to help you out to do the project, okay. So plan is to learn how to deploy a WLAN network, okay. So addressing, suppose giving you the specific data rate, the design requirements, I mean the throughput, the SINR requirement of a network, we will provide you the specific area, design of building construction and all will be given. So maybe the design of this GSSST lab and all GSSST whole building, or maybe the EC department, some structure will be given to you, and you will be given the task of deploying a WLAN network there. You have to confirm that actually if we are going by your guidelines, if we deploy practically, it will give at least 95 to 98% perfect results in terms of your coverage, in terms of your throughput, in terms of your received SINR. Am I clear? So that's the plan is for the sessional, how to do it, how actually the service provider do it, starting from the network deployment in the indoor environment to the network deployment in the outdoor. The same strategy we follow when we go for the outdoor network deployment. We deploy the base stations and we start actually planning the coverage that this base station can be given, okay. And this list is there with Sajahan Kuti, Rakesh RT, and also will be kept in the office, and we request you to note down here actually your, especially the lab you are allotted, your partner with which you are grouped to, and the machine number which is allotted to you, okay. I request the people who are having the laptop with you to follow the instruction given in the registration kit to create the login and password, so that actually we will be entering into the cloud of a company to use their software. So that login, if you apply for the login one day before, they may take 24 hours to allow you to enter into their cloud. So we will be doing our design in the company's cloud basically, but you need to create the login account to enter there. Why it is required? Because whatever the training we will give you in the lab on the first day, if you practice little bit after going back to the technology guest house in the evening hours, it will help you in the second day, because first day will be fully assisted mode, second day the problem formulation is given and you are requested to come up with your own designs there. Then the learning process will be completed. Don't worry, second day also the instructors will be with you to help you out, but the starting point and the design concepts we would prefer you to come up with. That will be completely your design, and believe me, for all the 30 groups the design will be different. Okay. So, you have the enough scope to learn and enough scope to come up with your own design in a wireless domain. Fine? Change. Yeah. This thing is to either we can circulate the copy of it in the evening hours if you are here, otherwise you just, we will keep it in the office, and please check your group name and the PC number there. We have tried to keep the people from the same organization in the same group. Wherever it was not possible, that there the separation has happened. Okay.
IEEE standard.
IEEE standard. So all that actually we are instructing them to come to the office. You keep this list to the office where when they will come, they can see and in the registration desk. Yeah, fine. So welcome in the session. Whatever we were discussing in the first half about the technologies, now the time is to revisit their corresponding standardization part. Now all the questions that you were asking in the morning about the data rate, modulation scheme, transmission technologies, we will go from the surface level to little bit deeper in this session, trying to understand what are the typical properties that we were designing top 10 technology design rules, how slowly the standard has adopted them today. Tomorrow morning we will be going further deeper to understand the channel characteristics and the physical layer issues for this high data rate communication. So, morning session was the superficial one, standard will be telling leading you towards a little bit next step deeper level. Tomorrow's class will be purely theoretical and the further deeper level. This is the whole frequency zone wise. If you travel, we can actually see the standardization, the development in the short range communication mainly divided into 3 parts. First part is the sub 6 gigahertz, sorry. The first part is on the sub 6 gigahertz short range communication zone. Sub 6 gigahertz, it means that starting from the 0 frequency to 6 gigahertz frequency, what are the standards currently are there. In that zone, Bluetooth comes into picture, 15.4 Zigbee comes into picture, whole WLAN comes into picture, and specially we have highlighted 2 parts, 11N and 11AC, because we are interested to identify those standards who already basically supports GBPS communications. So, the more thrust and all the discussion will be towards them. 11N and 11AC is there. Wireless body area network is not of very high data rate zone, but it is another short range communication which is really very important and getting integrated with our mobile devices. So, they are there. Next is the 3.1 to 10.6 jump, fast jump towards the very high, very really wideband communication zone is the ultra wideband communication supported by IEEE 802.15.4a. Finally, we will be entering into 60 gigahertz millimeter wave communications that are currently actually the boom and the standard research, everything is behind them. This millimeter wave communication comes under the broad umbrella of your 5G communications. Okay. 60 gigahertz is currently dedicated for the indoor communication support. Okay. Outdoor will be mainly on the zone of 28 to 30 to 35, that zone. 24 gigahertz is also the channel sounding is going on for the outdoor 5G communications, and its counterpart in the indoor will be supported, is envisages to be supported by the 60 gigahertz communications. So, we are there. We will also discuss what are the standards currently available from the WLAN platform, which is 11AD, and basically it started with the 15.3c, who are basically, this dot 15 is for the low power zone. From low power zone, the initiative started for 60 gigahertz for personal area network, and then from personal area to local area network, that migration happened with the dot 11 group people. Okay, that is the overall map. This picture we saw in the morning. So, again here we are, and mainly we will be traveling now over Wi-Fi, ZigBee and UWB millimeter wave. Let us see the chipsets, Wi-Fi chipsets and WiGig chipsets, the shipment announcement that has happened. See, if I see the WLAN whole chipset selling plan that was forecasted, we are here. So, see, till the last few years back, 10 years or more, almost actually 10 years back, when we were, the single band 11N was very popular. Then came the dual band 11N. Dual band means 2.4 and 5 gigahertz switching is possible. So, this much amount of the shipment was possible. See the jump here when the dual band N plus the AC came into picture. AC fast gave the speed of 1 Gbps, at least promised to give the 1 Gbps. So, not only the dual band switching, also the data rate hike was promised by WLAN guys, and so this was the huge market that WLAN chip could ensure. Later on, actually in the coming years, apart from this 11 AC, 60 gigahertz, the tri-band combination means switching from 2.4, support for 2.4, 5 and 60 gigahertz, simultaneous support, and which is will be enabled in your mobile devices, is coming up. Okay. So, 16, 17 onwards, as 11 AD has been already frozen. So, device manufacturing is on the process, few of them are already ready in the market there. So, we are expected to get next generation WLAN support in the handset, mobile handset, who will be having 3 features: can operate in 2.4, can operate in 5 gigahertz, can operate in 60 gigahertz. Okay. Whatever the data rate you want, you can select and your mobile phone can switch. This is the journey of dot 11. See, in the year of 1999, we started with 2.4 gigahertz and 20 megahertz bandwidth was there. For indoor, 35 meter was the typical distance that he was supporting, and outdoor it was the 100 meter. See the speed, only the 11 Mbps actually was supported. When the next generation came up in 2003 almost, with the help of A, the FDM came into picture, but then in G it enhanced, and the speed were 11 to suddenly 54 Mbps, almost 5 times up. And see the migration time almost within 4 years or 5 years, I was telling, right, 4 to 5 years you will see the sudden jump has happened. So, that jump happened, and people how they could support it is, they already occupied the 5 gigahertz band, and bandwidth was same almost with respect to 11B, but they could extend actually they could keep the indoor outdoor coverage range also same. That is a very big achievement. You are increasing the data rate, you are not compromising with the coverage zone, means really it is the improvement. But improvement basically came from the migration from the direct sequence space spectrum based standard to FDM based standard. See, from 54 to this 300 or 450 megabit per second, that migration happened really very fast. It is another 5 to 6 years gap, and we jumped 10 times. Now it is not 5 times. This 10 times jumping came with the hand of not only the WebDM, they already increased the bandwidth of operation from 20 to 40 megahertz. So, option was there like you can utilize 20, but now there is an option of using the double bandwidth. They also introduced the MIMO configuration. They introduced the concept of transmit beamforming. So, the beamforming is a new concept when it came with the WLAN. It is something like, if I know the location of my user, I do not prefer to go ahead with the omnidirectional transmission. I will direct my beams to locate you, and by that I can actually handle not only the interference, I can improve the received signal to interference noise ratio. My power of transmission, it is now focused and directed. So, it is the directional communication, the concept of directional communication slowly came up. Please remember here they never thought that user also can do it. They thought the handheld user devices will be of low end, they will be always having omnidirectional case. So, for the uplink it will be omnidirectional, but when the downlink will be happening, AP will have the higher power. So, we will go ahead with the transmit beamforming. That was the concept. 11N to 11AC, another 4-year gap. You have jumped from 450 Mbps to at least 1 Gbps, and theoretically they could promise up to 7 Gbps. Fine. So, if I go and see the journey from 1999 to 2013, over a year of 13 years almost. So, we have came the way from 11 Mbps to 1 Gbps. Okay. This 1 Gbps, this happened with again the increment in the bandwidth. So, 40 to 80 or 160 megahertz, and then the aggregation happened, the increasing the MIMO size, multi-user MIMO concept, and the beamforming came into picture. What is this multi-user MIMO and all? I will discuss little bit today. So, this multi-user MIMO and the beamforming again came into picture. Remember 11AC first told us that a very big jump is expected to happen next. So, hence immediately almost at the same time you see 11AD, they started the working group, study group and the working group in a higher frequency zone of 60 gigahertz, when 11AC was the development on the same 5 gigahertz band by increasing the bandwidth. Suddenly they also jumped towards the 60 gigahertz band centered around 60 gigahertz. They suddenly realized the huge bandwidth is available worldwide, which is not getting utilized for anything. So, they tried to see whether that can be utilized for the commercial purpose or not. So, the channel sounding, effect on the human body for 60 gigahertz communication, all those issues came up and they started evaluating it. And today it is a reality that 60 gigahertz chipsets are in market. So, 60 gigahertz, one basic plus point is that you see in the 11AC 5 gigahertz band I can maximum go up to 160 megahertz. By default in 60 gigahertz you will get 7 gigahertz band. Okay. Problem is again to handle the bandwidth, and here there is no restriction like ultra wideband that you have to just transmit with below the noise power level. That restriction is nowhere. So, the power restriction is not, so it can actually transmit according to the WLAN other standards. So, at least 20 dBm power you can expect to transmit, and then you have all the options as the power restriction is not there. So, the MIMO can be easily put, multi-user MIMO concept can be done. So, smart beamforming, all the antenna array structures you can play with, you can go ahead with a very nice kind of the beamforming architectures, and hence the speed suddenly jumped up to 7 Gbps minimal, and then in the second generation now they are fixing up it is minimum 10 Gbps and above. Okay. What are the issues that standard has already addressed? High data rate, yes. The good coverage, that is also yes, they can. Low power operation is possible because all of them are having the power control both in the PHY and the MAC. Concept of they have done the robust and reliable communication, connectivity is ensured, and security, each and everybody 11AC and AD, they are heavily secured communication they have designed with. Now, let us see what is the practical scenario. So, good question, because what he is she is asking is, I have a 7 gigahertz bandwidth, why I am getting only 7 Gbps, okay? Why is it not scaling up? When the fast standard came up with 11 AD, they just tried to, there was very big doubt whether we can have a communication at a 60 gigahertz, what are the other effects. So, they tried with the very minimal kind of the communication modulation schemes and all. There was no concept of the MIMO. Now, I will show the standard which has started up already to bring now MIMO on the 60 gigahertz. So, within 2 years, wait for 2 years, you will see that it is another jump, okay. Minimal actually 50 Gbps and all, suppose they have started talking about. So, multi-user MIMO beamforming, though I have written everything here, the 11AD only promises 7 Gbps without any MIMO. It is a single communication, no multi-user. They have proved everything without any MIMO communication, without any multi-user MIMO communication, but beamforming is there. Fine.
And modulation order?
Modulation order they have showed up to QPSK. Okay.
And here beamforming you mean if it is an indoor case, then if there is a station over here and if the access point is over there, then it will be pointing towards the device and then transmitting, or?
Yeah, beamforming means both way. See, actually fast beamforming are having different stages. First is the beam training we call, then beam forming, then beam tracking. When the beam training goes on, then it is the training of actually both the transmit antenna as well as the receive antenna to get aligned in terms of the direction of the arrival and direction of the departure of the rays. So, we give the training sequence to train them out. Okay. Once that training is done, then the beam forming procedure is followed. Okay. After that, the beam training, then the data communication starts, and after some time we follow the beam tracking, because we don't know actually what has happened to the channel. So, for that typical part of the packet after the transmission, we need to see once again that whether the alignment is fine or not, to check whether you are getting up to the level of the bit error rate that you have promised. You immediately you have received after the beam training and beam forming, it is a revisit. If it is not, go back, do it once again. So, that is the way. So, if it is only the transmit beamforming and your receiver is having omnidirectional antenna, it is easy to do. Okay. You need to identify only your user location. From the AP, you will be directing the beam towards him, and he is having omnidirectional antenna, he will be receiving everything from other sides. Okay. If it is a receive beamforming, then he is transmitting on the omnidirectional way some way, but you have to find out under all this omnidirectional way which way you are receiving very nicely, where the SNR is maximized to your end. So, you align your antenna towards that, that is my receive beamforming. Transmitter is not doing anything, but I am finding by myself which direction actually I am having the maximum signal to noise power. Towards that direction I will align my antenna. And finally, if it is both way transmit receive beamforming, this is training is happening for the both. Okay.
As you said, there is no MIMO, then how they are doing beamforming?
See, MIMO beamforming is a typical thing. One is the beamforming, you have the array of the antennas, jointly you are feeding the, you are changing the amplitude and the phase of those antenna array in such a way, a beam, yeah. So, you are forming a beam towards a typical direction, maximizing the gain of the main lobe and minimizing the side lobe. That is the one structure, and then on the top of it, if I am having MIMO, that is the MIMO beamforming, that is very typical structure. Okay, where we have to follow the beamforming for as in the RF section as well as in the digital section. We go ahead with the hybrid beamforming. We need to do the precoding for the MIMO and then follow the actual beamforming and training on the RF section, which we call the beamforming beam training. So, that is the hybrid beamforming we say. We cannot do it alone sitting in the RF or alone sitting in the baseband. Femtocell is the way the cell structure you are talking, and beamforming is a technology, as a signal processing technology that can be followed. So, whether it is a femtocell or picocell or microcell or macrocell, that does not matter. Beamforming is required whenever you are in a 60 gigahertz or 77 gigahertz or terahertz communications coming up for future, because there the absorption is so high that if you go for omnidirectional antenna, you cannot travel even 1 meter or 2 meter distance. I have to have a beamforming structure. Okay. This is coming because of the migrations of suddenly the migration of the technology, migration of the transmission frequency from 900 to your 60 gigahertz. So, can you see the migration now, because cellular communication was in the 900 megahertz zone closely, then they slowly came up, and actually nowadays they are trying to do something in the 23, 24 gigahertz. That is also not understood how to go ahead and cover the range. Suddenly I am talking about 60 gigahertz. So, the jump has to understand, and typical problems of the signal propagation and the characteristics that is changing when the electromagnetic wave is propagating at that frequency through the air. So, all the physics we have to understand that is happening now, and then start the system design.
And this is mostly short range would be indoor or even it is
Outdoor also. So, 60 gigahertz sorry, this millimeter wave communications, nobody is restricting that it should be always in indoor, but preliminary or primarily we started with indoor, because we understood by that time 11 AC. That is why. See the situation, lot of promises have been made, and where actually the devices are working with. Here these two graphs are saying what is the minimum support possible by the Cisco routers. This is the routers and development of the Cisco routers. So, when 11A or G came with this WebDM, so at least we could get 24 Mbps minimum speed, and when the standard promise, typically they promise that 54 Mbps is possible. Cisco router could not give you 54 Mbps. Then your high throughput 11N came, and minimal they could show 65 Mbps. Typically we could see actually 300 Mbps. Product maximum output was specified by the manufacturer was 450 Mbps, but standard promised that 600 Mbps is possible. Okay. See in 11 AC, so minimal was 290 guaranteed, typical 870 you will get always almost. Product maximum is when they gave the product maximum for a short but very favorable situation, they could show that they can give you 1300 Mbps, and 7 Gbps is the standard maximum they talked about. So, when actually very high throughput 11 AC came, so in usually we see first the standard will be released with lot of promises, prototype they will develop, they will establish that the link is possible, this data rate is possible. Then the vendors and the manufacturers will start, they take the technology, start manufacturing it, devise their own algorithm, incorporate it inside, and when they go for the field trial and the trial test, then they realize what is possible, what is not possible actually in the market. Okay. When they are deployed in the practical scenario, you will be able to measure what exactly is the speed you are getting when it is operating in the field. So, this is the speed that you are getting typically in the field. So, when the next, that is why the version after version comes up, then the service providers come back and say this is a drawback, we are not getting it at all. So, it seems that some of the channel characteristics is missing in the whole technology design, start revisiting it. So, then they do some kind of the modification in the standards, and then with 11AC second version or the wave 2 version I should say, they could improve the typical speed from 870 to 1730, and that is why your product maximization was 3.5 Gbps, where the standard is still in the 7 Gbps. So, another gap of 3.5 Gbps still needs to be achieved. So, the version after version, when you see the version 1.1, 1.2, 1.3, you will see that one by one the amendments are going on to reach the speed and whatever it was promised initially. Once that is close to the speed you are, suddenly they will change the technology to something, jumping to something else. That is the way research goes on. So, this is a gist actually. If you tomorrow wish to know which standard is doing what and what it is for, if I wish to do some research or some development in some area, which standard I should look into. 11A, It is for 5 gigahertz, data rate up to 54 Mbps. B, 2.4 gigahertz band, data rate up to 11 Mbps. D, it enables this 11 network, which is very funny, in the various countries where actually 11 could not work properly. So, what usually the standard does it actually, suppose some new technology is coming up, you need to know how the channel behavior is. Most of the people sitting in USA, they will do the channel sounding, okay, the famous groups who do the research in the RF. So, they will do the channel sounding, they will do the take the measurements, and accordingly they will fit the measurements to some statistical property. They will say that hello, this channel looks like a Rayleigh distribution profile. So, if you follow the Rayleigh distributed profile, you can maximize the transmitter receiver design, thinking that channel will work as a Rayleigh distribution profile with these parameters. This is the guideline with which you will start suddenly. Where the measurement was done in the situation there, their kind of weather, their kind of environment, their kind of all the territory structure and all, come and try to deploy it in China or India, it will fail definitely. No question, actually, it will definitely fail. Otherwise, you will get a much lower data rate with which you will be you have to sustain in life. So, this is the huge, and this problem escalates if you go for the higher frequency zones. So, the certain areas where they could not make WLAN even work, for that to make them work, they started a new group. See, so these are the corrections. So, after deployment, all the feedback comes back, then they realize that where is the gap and where the new standardization is to start up. 11E was the quality of service enhancement on the initial drafts. 11F was to add the access point interoperability, that I was asking, to extend the BSS to ESS. So, how actually one AP should work with another AP, at which level, following what protocol they should be able to talk to each other. To enhance the flexibility, I should say, they added the 11F. 11G is again compatible to make the 11B compatible with, and up to 54 gigahertz, whether you can 54 Gbps, sorry, it should be for up to 54 Gbps, whether you can come up. Security enhancement was done in 11I. Japanese regulatory extension was done in 11J, specific to Japan. Radio resource management enhanced in 11K. 11AM, they enhance the maintenance features, improvements, some amendments, they listed up all that, what they have done till that time. 11N document, they started with the throughput excess of 100 to 500 Mbps, because by that time service providers came back with the complaint that whatever the standard is promising, we are not getting it. So, enhancement on the fast roaming. So, WLAN initially was planned for the static zone. Okay. Now, people started deploying it everywhere. In a situation like a shopping mall and all, suppose also in some of the very big kind of the shopping malls, inside the shopping mall sometimes they are moving with the cars and all. So, WLAN is not getting their connection, you are not getting the connection properly with your whatever the what it was promised, and the cost of the sets that with which you have planned to proceed with. Then with the fast roaming, they realized if the speed is incorporated, that data rate is not coming up. So, wireless mesh network was addressed in 11S. So, this is a whole journey of 11 like that. Out of that, our interest is these two, 11AC and 11AD, where we will enter. AC is a very high throughput and AD is a 7 gigahertz bandwidth, 60 gigahertz communication. Another information is here. You were asking, right, that 60 gigahertz, why he is giving 7 Gbps only. So, here the next generation 60 gigahertz had already started, it is going on. So, they are targeting 20 Gbps, do not worry. Okay. So, wait for 1 hour, 1 year or 1.5 year more, you will see that the technology is already frozen. Okay.
And this data rate is at physical layer?
Data rate is in mostly physical layer, mostly physical layer.
In the graph what we were seeing router, at router we were testing, so how we are comparing that networking?
See, actually there are the different draft documents. You see that for Phi and MAC they release one draft. Okay. they will see the for higher layers network and the transport layers, there are some other drafts and the documents, because the technical language is different from the FiMac to the network and the application and the higher layers. So, you will see there. So, for example, in the file layer, if we try to see the data rate and see what exactly is the quality of service, we will talk in terms of bit error rate. Once you are in the MAC, they will talk about the packet error rate. You go up, they will talk about the frame error rate. So, these things are not same.
But the
Comparison either will be in the packet error in terms of the packet quality of service based than the data rate, right. Only data rate does not mean anything, it should be always associated with your error. So, if I am not getting 10 to the power minus 5 bit error rate, then telling that actually I am getting something suppose 1 Gbps rate, what is the meaning of it? Okay. So, again another important part of our interest is the Bluetooth. We will enter here little bit, we will also enter with respect to UWB, we will enter here understanding 60 gigahertz, and band and all we will just touch about what exactly the standardization is, what they are talking about. And this whole list is here for your reference based on your kind of interest and your alignment, your company specification, where to go, how to start with. Otherwise, finding out this information itself is a very big task. To search where to go, where to find out the main material, to read the document and start up with. This is a comparative statement once again that we were doing for the ZigBee. Yeah.
In the previous slide, there was something called key management. Key, you mean security key or?
Security key management protocol. In the morning I skipped a slide where actually the authentication was going on and 4 key handover was also going on in the WLAN. So, how they designed those keys for the, these are the security keys. So, you need to enter and understand what kind of the security is provided for the network. That is a separate class is required itself for the security to make you understand how that protocol is according to the key development. So, those key management protocol is addressed in 15.9. ZigBee, Wi-Fi, Bluetooth and UWB, if we compare where are we and all, I would like to show you only the operating frequency migration and their associated latency that we could address. So, it has really came down for Wi-Fi and then Bluetooth also under typical applications where they are going on. So, you will see that more or less the application wise common there, home environment, entertainment world, medical world and industry. Next, let us start with sub 6 gigahertz SR. Sub 6 gigahertz, the leading people is Bluetooth. Bluetooth initially they developed the standard. After that, they gave the task on the study interest group or SIG, we call it the Bluetooth SIG. They took the lead role and then they are continuously going on updating it. Some of the important feature is this is the interoperability between the manufacturers was a problem, and so the Bluetooth device address was a problem for them from the first version. They rectified it over 1.1, 1.2 they included the faster connectivity, enhanced the data rate in the version 2, simple secure pairing they did in the version 2.1. And then they included UWB support for V3 because UWB was coming up, Bluetooth suddenly got shaken and they immediately started collaborating with UWB networks and showed that we can coexist. So, we are friend, something like that you have to establish immediately. So, network exchange, information exchange, security wise everything should go hand in hand. Then they came with the Bluetooth Smart where the classic Bluetooth, Bluetooth high speed, Bluetooth low energy, everything were clubbed, and this is a combined smart network that they came up with. So, we can provide a smart home, everything operated in the Bluetooth, and your devices are having different zone in terms of the energy consumption, different zone in terms of the data rate consumption, different zone in terms of the type of the communication you are doing, the burst communication or the streaming communication or different applications you are dealing with. So, everywhere Bluetooth is there, that was the concept. So, low data rate, low energy, high data rate, everything they combined. All the specifications that came from the Bluetooth platform, they tried to aggregate. I would like to highlight here, so Internet of Things Bluetooth is the main container, physical layer container there. And from Internet of the Things, now they are actually developing some standard, now it is going on, where they have doubled the data rates and they have quadrupled the range up to 300 meter. So, short range up to 300 meter is not actually a matter of joke. They started with 10 meters. So, data rate is heavily increasing, power consumption is decreasing, and the range on the top of that is increasing. So, see actually the multiple opposite things are happening simultaneously, and the standard is coming up, technology is coming up. These are the very fundamental and the key features that Bluetooth low energy will operate up to 150 meters open field. It is tested and it is operating. Power transmission is 10 dBm. Your maximum current consumption measured on the chip is 15 milliamps. Latency it can provide 3 milliseconds. This is a very, very important task for the scheduling. And the Mac guys who are designing the routers and the scheduling algorithms, because latency, control of the latency and minimization of the latency is another criteria for the Mac design, Mac protocol design. Failure, we are talking about the data rate, energy consumption, extension of the data, extension of the covering zone and all, but Mac is on the top of that, is putting the constraint of how fast the packet should be transferred from the network. So, minimizing up to 3 milliseconds is a very big deal, it is a very, very big deal. And mode, what are the modes they can support? Broadcast, connection, event data models, read, write, everything. So, that I was telling in the morning, that you should have the not only the broadcast, not only the multicast, not only the unicast, that also for the multicast you should have multicast channel, for multicast you should not have the unicast channel. So, all those parameters is already addressed by Bluetooth. Users worldwide currently using Bluetooth. This is typically, if I see the stack, low energy architecture of the Bluetooth. Broadly it can be classified into 3 parts. One is the application, second is the concept of a host, and third is the controller. The controller is, you will see that a physical layer, lower MAC layer, and the test mode they are having, they are calling something called as a direct test mode, where actually controller can test the connectivity with the users on the fly. For all those protocols, they will be lying on the controller itself. The host controller interface is something that you have to put in the stack. LLC, protocol attributes, security management, generic and the access profile as well as the attribute profile. These are the typical layers and the stack that is posed inside the, is kept inside the host. And application, they are typically are placed on the application layers, given by the application layer. So, this concept of the host and the controller, division of the OSI layers and the stack protocols, it first came inside the Bluetooth. This was also basically done to reduce the latency up to 3 milliseconds. Here there are 3 different operations of the stacks. One is the basic rate or extended data rate stack, another is the single mode stack, and third is the dual mode stack. Basic data rate or the extended data rate stack is having the basic data rate RF, then the link manager is taking care of as a MAC. Top of that you are having the LLC and the adaptation protocol layers, RF communication protocol, serial port profile, and then the communication is up. Here the main gap is, here is a low energy RF, then the link layer, L2 cap, attribute protocols are there for attributing towards this low energy or emerging protocol for the low energy. So, see here they first realized also that energy consumption needs to be addressed from all of the higher layers. It is not the task of only the physical layer. Sitting in the physical layer, if you address the low energy, it is not going to help you in the network level. The total network level energy consumption, if you try to reduce, then you have to have some protocol sitting on the higher layers also. And what this dual mode stack is, this is the latest and the most intelligent kind of the Bluetooth stack, where we can switch between these two wherever is necessary for which purpose. This is a 15.4 low rate WPAN, basically for the ZigBee. It was a device for the low cost, low speed and ubiquitous communication between the devices. And see, if we compare it with the Wi-Fi, it is having your less power consumption because its bandwidth is also small, and that is why in the morning I was saying that for the very low data rate transmission it was fast coming up. He first targeted the 10-meter distance, and see the transfer data rate is only 250 kilobit per second, where from the ZigBee kind of ZigBee, RFID applications came up. The operating zone will be varying from 868, 915 and 2.4 gigahertz. These features we have seen in the morning, so I am skipping. 15.4 they are having two different PHY. One is a single carrier based PHY basically, and having 868 to 915 megahertz DSSS based PHY structure, where the 11 channels they could get in this zone. When migrated was 2.4 gigahertz, the same spectrum based communication, but the 16 channels they could operate. And chip rate, if you see, they could go up to your 2 mega chips per second if you are utilizing the offset QPSK. This is a typical stack wise how they are doing what. Physical layer is understood, MAC is understood. See, in the network layer, say this section of the network layer is dedicated for the network organization, route discovery, message relaying. But here see the security service providers and security function, they have dedicated a section. They have also dedicated the application support, where the device binding, messaging will be going on. And ZigBee is having a very important task. See, how will you know where the next ZigBee device is? I mean, the device discovery is now becoming a key role to play in the short range communication. Finding your peer is a very big task. So, for that you have to develop some kind of the mechanism, which we also call the development of the protocol for the device discovery. So, several mechanisms and the layouts came into picture, and this layer ZDO, the ZigBee device objects, he is dedicated to take care of all that. So, whenever you will develop the software, supporting software for supporting the protocol stack in a ZigBee device, you have to keep a dedicated portion on the software who will take care of this device discovery. Yeah, you were asking something? ZigBee usage. See, the smart home people usually think that controlling the shade of the lights inside, opening up the curtain and all. So, it is a bungalow type and pattern. So, something actually you wish to control on the upstairs, something, I mean the lighting control, maybe switching off the TV and all. So, they thought that all that operations can be done using the ZigBee initially. In an industrial purpose, suppose this automatic movement of the doors and all, and monitoring whether some tracks and all are coming here or not, what is the queue, how what is the length, if there is something they are in the queue and all, how many number of them are in the queue. So, for easy control of the inventory in the portion of the industry, and to open the shut and open the doors and all, there were the places for the ZigBee applications. And heavy engineering section also, so control of the flow, measuring the control of the flow also, they used ZigBee. This was the WLAN channelization in the 50 gigahertz we have seen in the morning. 11N. So, it was the starting part for the 11AC. So, we have to quickly brush up what 11N did. N was a WebDM based multi-carrier communication. He supported two different bands. Remember, here we migrated up to 64 QAM, and support for the 4x4 MIMO was actually demonstrated in the device, and all the 11N device today available in the market, they are operating with the 4x4 MIMO. 11N in that sense was really very successful. They could demonstrate the speed, whatever they were close to the speed that they promised, and the 4x4 MIMO for a indoor operation kind of short range operation, that also with the high speed 11N could show it. These are the other features of the 11N. where the symbol duration of the wavedim was around 4 microseconds and different coding rates they utilized starting from half to 5/6. Both actually the LDPC code and the DCC code were opted in the physical layer. This is a typical slide to make you understand what is the meaning of multi-user MIMO. This is a single user scenario, one stream. You have only one stream transmit diversity that we were talking about. This is a transmitter who is having the diversity capacity, but the receiver is having no multiple antennas. So, this is a typical multi-input single output case which we are seeing here. Opposite is like this, where receiver is having your diversity and transmitter is not. Maybe this is AP, first AP was transmitting in the downlink and then AP is receiving on the uplink. The another situation is where your multiple inputs are there and then actually you are trying to get almost, actually this is a one stream STB, means of your STBC you are putting the diversity multiplexing gains inside apart from the diversity gain. So, these are not using any kind of your coding scheme and STBC if you are putting on the top of it. MIMO 2x2 basically is a structure where two different streams they are multiplexing with each other. You have two different antennas simultaneously, you can transmit two different data streams, as simple as that. Two stream when they are multiplexing with the transmit beamforming, so you are having the antenna array elements. Some of the antenna array elements they are utilizing to form your beams to get the beam structure, and then the MIMO is there on the top of it. Multi-user MIMO is something here, it should be 4 stream and 3 users. You are having 3 receivers and 4 different stream of the data you are having to transmit from the transmitter. What you will do, you can target actually by proper beamforming to target and give the dedicated antenna structure to address the another receivers, where the other 2 antenna structures are going by the MIMO communications. So, as a whole this is a multiple users you are targeting and the MIMO communication is also going on. So, multi-user MIMO communication, the fundamental structure is this. Okay. It depends how many number of the antenna you can actually utilize here. See, we could actually give for even it is example for 11N to 11 AC. AC supports up to 8x8. So, beyond 8x8 in practice it is not possible, but if you come to 60 gigahertz and you ask me actually what is the MIMO communications and all are there, people are talking about 1024 cross 1024. It is not 100, it is 1024 cross 1024 antennas they are coming up. No, that is why they are coming up with a virtual antenna array. Okay. That is why they are talking about the cooperation of the multiple antennas. So, jointly actually they will form the beam. Yeah, they are specially not co-located, they are distributed, but they are synced in such a way that whole specially distributed them. Suppose the antennas are on the relay networks, placed on the relay networks, specially distributed, all relays are jointly forming the beam. So, that concept is coming up. So, that is why they are talking about 1000, but actually if you see in the IISc Bangalore, the group Professor Chokalingham's group, they have demonstrated actually that co-located also 1024 antennas they can manufacture. How and what exactly will be the use of this co-located 1024 antennas and all, that is another question. But definitely actually if I think about giving a structure wireless connection for tomorrow's server room, server to server or base station to base station, backhaul communication going on. User end difficult, user end actually we should be like this. Suppose you have a 8x8 8 antenna structure and in this room another handset is there who is having also 8 antenna structure. So, it can be now nicely cooperative mode, it is becoming a 16 structure of 16. So, like that the way you are going for the cooperation, it is increasing the strength and the resource of the network. From the network point of view, you can think yes, it is possible.
But anyhow, for 60 gigahertz, you can increase the number as the wavelength decreases.
Exactly, because your lambda by 2, if you go by that, actually you can, that is why actually people are thinking that large MIMO networks, large MIMO antennas, which was earlier seems to be totally wrong, they are becoming actually possible, because if I think about 60 gigahertz, all those 1024 can be easily integrated. True. Actually, if you are seeing that from the user end, how far we can go, whether it is the number is 32 or 64 or 128, 256, what, it totally depends upon whether you can manufacture the device or not. If tomorrow RF people come up and tell, let us see, I can give you that whole structure, the whole 256 antennas are here and you can do the special multiplexing over these 256 antennas.
The more number of antennas mean more processing, so more power.
No, power issues and all, these are all the RF issues. Truly what he is saying, that suppose 256 antenna structure I am having, how will you devise the control? I mean you are trying to change the amplitude phases of the whole array, right? So, you have to devise the mechanism to do that, and that also with the finer level, because if I divide 360 degree over a 256 number 256, so can you change, you see the fine resolution wise I have to change the shift, the phase shift of the typical antenna points. So, all that migration, that minute resolution and the control, if it comes tomorrow from the RF section, yes, this technology is ready to come. Okay. These are the problems. These days actually the theory wise and communication theory wise and the simulation wise, idea wise, the theory wise ready, fine. We are doing a lot of things are together, but whether it is implementable, whether it will be able to see the device or not, that totally depends upon the way the RF people and the RF components they are actually coming up. So, with the trust that if this is the way we have migrated, first Phi come up with some ideas, simultaneously the RF people start struggling with it, they come up with the solution, one day we see the aggregation and the technology is they are available in the form of something in the market. Okay. Actually, I remember the days when people started talking about 2x2 MIMO, they were not getting any result actually for 2x2 MIMO. Suddenly 8x8 MIMO structure and this proposal came to the standard, and there was a huge noise in the standardization itself, that we are not getting, at least really you are not giving us a very good QoS with a 2x2. Where is the result for the 2x2? We are unable to deploy it. You are talking about 8x8 MIMO. Today you see for the short range 8x8 MIMO is there already. So, this is the way technology comes up. So, never ever trust that is not possible. There is nothing under not quote unquote not possible. AC bandwidth up to 160 megahertz to 56 QAM, and spatial string of antennas 8 up to 8 they could demonstrate, I showed. So, multi-user MIMO concept they could build up. So, under those 8 antennas, few of the antennas they will be dedicating to address some of the user, another antennas either in the MIMO fashion or in the non-MIMO fashion they will be addressing to some other users. So, as a whole it is a multi-user communication going on with the MIMO inbuilt in it. Okay. So, this was the road and the forecast ahead when 11 AC was coming up, but this time period is over, and remember this, by this time the 11 AC 3.6 Gbps is already achieved, and now that is why actually AD is out. So, this slide is not that much relevant with respect to the roadmap. Body area network, let us little bit go ahead and switch little bit from the high speed to see what is happening in the zone of the body area networks, because all of our today's gadgets they are getting integrated with this operation of the body area networks. This standard, when they realize that it is required, the whole requirement came from the lifestyle that is happening, that we are going through, and in future it will be also coming up more and more stringent. The tension that we are having in the day to day life, the lifestyle and the food habits and the kind of the activity our means tech savviness, I should say. The young generation continuously is playing with either with their mobile phones, and out of the 24 hours, 18 hours they are with their computer screen, they are loving all those. So, the change that is happening in your structure, medical structure, and the biological support is not going to help you out with this tech savvy life and all. So, to help you out, to get you aware what exactly you are doing, what is the health situation of yours because of this kind of the day to day activities, if you wish to know. So, they tried to make the device, your handheld device and the mobile phones, your supervisor kind of in terms of your daily health analysis and the long term health analysis. So, the body area network, the requirement of this change in the lifestyle, that ignited the requirement of the body area network activity in the IEEE standard. Okay. Fast those stuff came, high speed requirements and all, network, internet and all became very popular. It changed the social life of us, and then suddenly the body area network came up as a mushroom kind of. So, they tried to trigger and control the additive service to your mobile phones. Body area network, you understand that maximum 5 meter is required for the communication. The piconet density will be 2 to 4 networks will be there per meter square, and 100 Mbps maximum will be the network throughput. It is a network throughput. So, the link wise throughput will be at least 1/10 of it kind of, or maybe 100th of it, depending upon what kind of the data you are streaming. Latency is 10 milliseconds, but remember one thing, the wake up time for all these devices and the emergency communication, that should be always very highly reliable. For example, emergency signaling that should go over this kind of the network, that should have at least 99.99% of the success rate, otherwise you are in high trouble. So, the when band came up and the standardization was going on, they gave us actually one very critical application, that whatever you do, whatever the specification you come up with, you demonstrate with 2 standards, with 2 criteria. One is actually that you show that the emergency signaling, design of the emergency signaling and its actual communication with that signaling is possible with 99.99% reliability, success rate should be that high, and the latency is really very less. Okay. The latency they started with, if possible you keep it within 1 milliseconds kind of, that was very hard to keep, and then they ended up with this 10 milliseconds kind of structure. See why actually this emergency signal and all is very important. See the situation where you are putting this band network, patients in the ICU full time watching and actually giving a dedicated person sitting there is a trouble. So, wireless network is there. After operation, critical operation of the heart, you are back to home, but anything can happen at any moment. You yourself will only be able to realize that something has happened. Prior to that, the sensor will sense it and the communication will go to your doctor. So, those kind of the applications came up in people's mind, very critical, means life critical all the diseases, to have a good observer of the life critical diseases. For that the band was dedicated for, and till now it is like that only. Okay. Tomorrow body area network is extending up to that. Professor Andrea Goldsmith, she was giving the lecture in the Globecom 2011-2012 time period. Her group is now actually dedicated for doing a research for the patients who are suffering from Alzheimer's. They could locate that the problem is what you know, only maybe one neuron, about a small area of the neuron, there actually the communication is not happening. Because of that, the whole mental power, remembering power, it is going off. So, her proposal was, let us develop, put a chip, wireless chip into those zones. So, wireless will do the connection. We will tap the biological signal, transfer it to electrical signal, establish the communication, and then you transfer it to the biological signal, and the disease is over. as simple as that. Nobody, people were so silent, they were actually not believing what that lady was saying. But actually today whenever I see the papers and the medical journal and all, this is the only way people are thinking of. Tapping the brain signal, maybe actually if it is not implanted inside your brain, actually you tap the signal outside and try to locate the area and the zone of the problem, and you try to establish the wireless communication maybe from outside. If it is not inside, can you do it outside? And how to propagate everything throughout the skull and all is the other portion. The biological signal and then transfer it to electrical signal, do the communication, send actually back it to the biological signal. So, develop the sensors who will be able to change the biological signal to the electrical and electrical to the biological signal, all are in the research problem. See, actually if you try to see these days, the whole research is the biomedical signal processing. If you see, you will see all the pulses that are generating inside our body, they are actually basically they are the electrical signals. Each and every movement of yours. Do you remember, actually I told that already in the band we have taken care of the implant devices. In the implant device, the first problem that I told is you cannot charge the battery. Okay? There is a very good mechanism, actually it came up from Samsung, that when you are moving, at what speed you should move, and every step of your movement there will be a generation of the electric pulse. From that pulse, actually that battery of that implant device can be recharged. So, what are the movements you should do so that your battery will be recharged internally? Okay. It is, I mean, it is amazing if you can think of the problem statement. So, when the ban was going on, no, the whole standardization was getting developed, it was really very interesting to hear what are the problems and how the solutions will come up. It is very, very hard to understand actually when you enter into the biological field. So, when they are talking about the trapping the and changing the biological signal to electrical signal, that means actually the development of the sensors also to understand actually the electrical, small electrical signals that are generating, how to capture them, how to analyze it, how to put it, utilize it for your wireless communication, and then actually bring it back to his own domain. Okay. So, see, actually though it seems to be a very, very futuristic, that kind of the operation, that Alzheimer's in future will be not there because of some gadgets putting on your head, you can solve the problem, or putting some implant device inside. But the research up to that level people are thinking of, at least the message is there. So, these are typical uses. You can wear it, you can implant it, whatever you wish to do, you go ahead with. So, these are the few standards and the frequency bands where the W band is working. Quickly we are migrating towards the next frequency zone, 3.1 to 10.6 gigahertz wireless body area network, ultra wideband networks. We have seen this picture in the morning that we are transmitting very short pulses, and in the frequency it is actually taking a huge bandwidth. Smaller in the time domain means you will be occupying a very huge bandwidth in the frequency domain. That is the concept of UWB. Problem of UWB we have also discussed, that this is a minus 41.5 dBm per megahertz transmission zone, where everybody, GPS, your Bluetooth, 11B, G, N, cordless phones, microwaves, everybody is transmitting with higher energy. And the 11A, who is actually sitting here over the UWB spectrum band, he is the main person who is giving the interference to UWB communication. UWB has to stand. Challenge, if you see, the main challenge is that, means how will you recover your own signal, and also how will you devise the mechanism to remove the interference from the high power transmission. These are the some UWB communication scenarios. So, WPAN, positioning, geolocation, we have already discussed about all that. UWB communication feature, if you see, it is a low transmission energy, it is less than 1 milliwatt power will be dedicated to you for your transmission, and 200 Mbps within 10 meter was the very fast generation. After that they migrated up to 1 Gbps. So, extremely difficult to intercept. It means you have already encrypted your signal. Somebody to detect what is going on with your signal, it will be very hard, because others are actually the narrowband transceivers. They can, even if they wish to capture your signal, they will be able to capture your signal over their small bandwidth, and over the small bandwidth something be buried in the noise. How to predict that, how to analyze that, how to get a meaning of what you are transmitting is a very tough task. So, UWB by default is very secure communication. Okay. And cost wise also it will be low, because the transmitted power itself you are dealing with is very low. These are the standards typically that UWB dealt with. 15.3a proposal came up first in 2003. Then they migrated to bimedia MBOA alliance, and multiband WebDM based file specification came up. Then they migrated it from IEEE to ECMA. ECMA is another European board who standardized the others wireless communication wireless standards, and in ECMA 368, 369 the FiMax specification was documented. 2006 the Bluetooth also adopted multiband WebDM concept. So, there was a migration between, already it is existing that all the Bluetooth devices they can coexist nicely and they can exchange the information with the UWB networks. Remember, one guy was asking in the morning that how will you provide put the barrier of restricting or saving your own UWB network, when because others are transmitting at a very high power. So, jamming is very easy, I will easily jam you. Then I answered actually that you have a very huge bandwidth. Let us see how from the standard itself they have taken care of this fact that somebody can jam me. MBUFDM is basically that. Apart from MBUFDM based MBUFDM, they came up also with direct sequence CDMA based structure. Plan was you have a whole 7 gigahertz band. In between 5 gigahertz band WLAN is standing. Why don't you divide it to hubs? So, first hub and second hub, you transmit here and here only, and WLAN from WLAN you will never get any interference. That was the proposal from Motorola. The direct sequence code division multiplex based whole research they initiated. But question is, in the high gigahertz range you are actually also missing out this zone of the spectrum. It is not a good part. Why don't you use that part? Why are you leaving it dedicatedly for the WLAN? Why can't I use it when because all the time WLAN is not on, right? Even if they are on, I really don't know how far they are from mine. See, if they are very far from mine, so they won't put much interference to me, it is also possible. So, why am I losing that amount of spectrum? They came up with this unique structure. This is a multiband WebDM. What they did, they took the whole 7 gigahertz, and by definition you can you have to have a 500 megahertz wide signal to call it a ultra wideband, divided the whole bandwidth by 500 megahertz chunk sub channels. Then they did something, a band grouping. Band grouping means each and every, this first 3 band will be called as the band group 1, band group 2, band group 3 and all. Then they devised a WebDM signal within the band. Then what is this multi-band? So, suppose you are a user, you can utilize all these first 3 bands, because initially they came up with the idea of using only 1.5 gigahertz. Then to avoid the interference, what you can do is, now you can hop over the bands. How you will hop over the bands? There is a typical time frequency pattern for hopping. The pattern for hopping for you and the pattern for hopping for the next person who is also using the UWB won't be same. So, when you are transmitting your signal, it is a time over time frequency hopping. So, frequency 1, frequency 2, frequency 3 is there. Your hopping pattern may be 1, 3, then 2, and then the another guy will be 2, and then 3, then 2, sorry 1, 2, then 1, then 3, like that. So, if I can go by that, so within your network getting the interference from another UWB user will be minimized. At the same time, if somebody does not know how am I hopping, how he will actually or she will jam my signal.
It is similar to FHSS.
It is not a spectrum going on. So, that is why it is frequency hopping WebDM. I should say it is frequency hopping WebDM. It is a time frequency hopping they are saying, because later on they did the hopping over the band groups. So, you have two different kind of the hopping structure you can proceed with. One is within the band and then is actually over the band groups. So, their double layer structure and the double layer security structure is there for this time frequency hopping multiband wave DIMM, and it became a very big success also. This technology itself is a very nice, though it is not getting used for UWB, but multiband wave DIMM, this structure, this concept, it was very well acclaimed in the wireless domain. Problem only here is very fast you are hopping, right? Okay. Very fast synchronization is also required in the baseband. Second important thing is your ADC DACs, they are actually needs to be designed at least for 1 gigahertz sampling rate. Okay, they should sample at 1 gigasamples per second, because 500 megahertz wide signal you are dealing with. Number one is ADC with 1 gig, that time was a very big question. So, if you deploy that at least 2 gigahertz ADCs, nicely you can reconstruct your signal. Then the people like the compression sensing guys and all, they said that okay, you do it, actually we will do the compression sensing based sampling, with the less number of the samples we will do the signal processing. Then the question came, with the less number of the signals you first need to synchronize, right? How will you do, how will you extract where the hopping is going on, because what will be the hopping structure receiver won't know. So, even if he is knowing, you have to do that hopping and extract the information. You extract the synchronization information time frequency, then you do whatever you wish to do with your compressing sensed based sampling and all. So, those questions came up actually, very genuine question came up for this multiband wave DIMM, and wave DIMM is inherently sensitive to your synchronization problems. So, it was escalated when multiband wave DIMM came into picture. 60 gigahertz next is the last part of the talk, the 60 gigahertz millimeter wave, the short range communication and the standardization efforts. This is the channelization part and the available bandwidth in the 60 gigahertz. If you see worldwide, at least in the Europe you will get the whole 57 to 66 gigahertz, up from 57 gigahertz to 66 gigahertz. So, centered around almost your 60 gigahertz you have a 7 gigahertz, almost 7 gigahertz wide band. Why do we say it is a 7? Because it is not uniform over all the countries, it is very minimal band available over Australia, but if I see USA, Europe and Japan, so 60 gigahertz communication and 60 gigahertz receivers, transceivers, whatever is designed based on the 7 gigahertz concept should work. At least you should get, this is not like that you are not getting even a single channel. So, whole 7 gigahertz bandwidth they have divided into 4 main channels. So, approximately each and every channel is having roughly 2 gigahertz kind of channel bandwidth. We were few minutes back talking about 500 megahertz. Okay. We talked that it is very hard to design the receivers. Now, people suddenly are dealing with 2 gigahertz bandwidth, signal with 2 gigahertz bandwidth. Okay.
For India, no channel has been allocated.
India. See, actually our situation is we always follow Europe and USA. We are very fond of following USA. We never realize that we need to devise the design according to our requirement. So, whatever the research currently going on in India, unfortunately everything is based on whatever the data USA is giving to us. So, our research outputs, frankly speaking, these days it is for the device that will work on the US and Europe, it is not for our country. Main problem is that we never do the kind of the channel sounding and all, and then take part of the, even if you are doing those channel sounding and all, you have to make it approved in the platform like IEEE. So, you have to have your presence in the standardization and then go ahead with all those painful stuff of showing that it is India made kind of all, and then you make it okay by them and then you implement it. Otherwise, anybody who is traveling to your country and the 60 gigahertz based some device he is carrying, it won't work in your country and all. Though USA is not getting bothered about that, but we are very much bothered about. Okay. So, these are the very basic problems in the social structure, mental structure and all that. Definitely, we do not take part in the IEEE standardization. Who will hear our voice? We do not have any presence in the IEEE standardization, never till now. Only in, from IIT Madras, one small group actually had some presence when the 4G modification was going on. So, very small amendment, very small contribution they had in the IEEE standard of 4G release 10. But after that everything is again stopped. So, we are very good in doing the research, but we do not do research for our country, that is true. So, nobody is bothered where is India. I mean, whether in India something is available or not. Even at the government level, they are not bothered about releasing or actually announcing some kind of the waveform or some part of the spectrum which will be dedicated for the 60 gigahertz communication for India. So, once it is not allocated or announced from the government level, so why will you do your research?
And one of the main reasons is that manufacturing, not manufacturing the device. Because China, Europe, Japan, they are producing the device, and accordingly the market is global.
Two things are there. Do not talk about China. China, what they did, you know? China 4G, have you seen what Huawei has done? They never follow the IEEE standard. They never participate in the IEEE standardization. They do not bother about what those guys are talking about. They never see the standard. They develop their own standard. They do their own kind of the channel sounding, and they deploy their own network. So, China 4G network is working for Huawei that has no connection with the IEEE 4G standardization. Okay. So, they take the whole pain off from the ground level, even from the negative level. They start doing the channel sounding, tracing and mapping that whole stuff with the statistics, develop the labs and do the research, and then develop the systems for themselves, manufacture it in house and then show that it is working and deploy it. For them it is as simple as that. Yeah, it is 4G because it is actually following that data rate, that coverage zone, that support of the services. China made 4G. Yeah, it is there. So, but unfortunately we are not there.
Participating in the kind of channel estimation and
Channel sounding it is. No, we don't do. We don't do, unfortunately.
why is that?
We prefer actually to go from here, join Professor Rappaport's group there, who is doing sitting in the New York State University doing actually the channel sounding for the millimeter wave communications. We go from here and join their group and do the work for their country. That is our trend. It's immediately actually, if you ask anybody who is sitting and actually is, studying from IIT, even after BTech, MTech, PhD, the first task you ask them, where do you wish to go? I wish to, if you are a very good student, your first target is to go for the PhD or postdoc in Professor Rappaport's group, Professor Vincent Port's group, or Professor Mauritius group, like that. Definitely. Do it for yourself first. So, that is the situation. We do not manufacture. If we do not start manufacturing, that is why this made in India kind of stuff, Modi government is starting pushing everything. But this is not our tradition at all. We have never, we forgot totally to do something for our country specific stuff. Manufacturing, research, planning, everything is missing. And 4G, for whole infrastructure of the 4G, most of the things we are purchasing simply. Funniest thing is, they are charging us heavily for the maintenance of all those base stations and the devices, network devices. We really do not know if they are failing. Sometimes we are calling them, their engineer, to come and then set up everything. So, what for our engineers are? They are actually sitting and according to some test parameters, every day they are just putting the ticks whether it is going well or not. And we have also developed our skill to develop the very nice software codes for it, and then we are selling it to them. That we are doing. So, software wise we have developed, but actually the technology, bringing the technology to the practical field, we are really not up to the mark. "60 gigahertz communication." So, the gist, we are having a 2 gigahertz wide bandwidth. We are problem is there are very limited interference and all due to the very high propagation loss you will be having. 60 gigahertz the antenna gain, it is mandatory for you because your loss is actually very high. Loss is high, so interference will be less, but loss is high, your actual communication will be lost. So, you need to put the gain, and that gain should come from the antenna structure. Your high propagation and the penetration loss is the main problem. Your directional deafness will be problem because you are receiving highly directional communication. You move the direction little bit more, you are lost, no communication at all is possible. So, deafness is another problem. If you are not aligned properly, then you are susceptible to link blockage. You have established very nice, you have not shifted, somebody came in between and standing. It is a human blockage, even with the human blockage your communication is lost. So, that possibility is there. So, you have to be aware of all these problems, so that your network can be susceptible or can be devised to give the protection against all that. ECMA 387, IEEE 15.3c, wireless HD and 11AD, these are the standards parallelly working for this millimeter wave communications. They have their own kind of first level or first generation kind of or first generation of standardization activities already published, but all of them are active and going on. Deafness means I am highly directing to you, I am the AP you are receiving, you move little bit, this direction is lost, your whole SINR is gone. It is not the omnidirectional communication going on, that so that you move little bit and you can hear even, you can't.
But it can be changed, no?
It is, it can be definitely. So, then you have to devise, right, what should be the solution.
Just by changing the parameters of the antenna or for converting the antenna to
Where is the time?
antenna.
Where is the time? If I am using the omnidirectional antenna, I cannot move even 1 meter, whole power is lost in omnidirection. That is why I came to the direction. Now, if I am putting you in highly directional way, you are directing, I am also directing. So, the SINR is maximized. Now, two basic problem, you move little bit or I move little bit, connection is lost. Somebody came in between and blocked the whole path, highly directive path, pencil beam kind of structure it is. So, somebody blocked the communication, I am lost. So, what to do with all this? A typical situation, in a piconet, how the communication is going on. Here is the device 1 and the device 2, and this is the PNC, the basic structure who will be actually the controlling dedicated for broadcasting the controls commands to all the devices, and he is another central device who will be exchanging the beacons and streaming the audio video, streaming the audio also to all of them. So, simultaneously both of them are possible, and see high data rate as well as the low data rate support, keeping in the mind that different kind of the application and service needs to be supported for the millimeter wave communication, that is already taken care of. 15.3c, this is a fundamental concept of the single carrier phi, high data rate and the low data rate phi, and the corresponding features. I am not going inside that. 15.3c channelization is also same like the 11AD. This is a frame aggregation by means of which they tried to expedite the process or the communication, minimize the communication time, minimize the latency, where actually in the frame the data units, there is a plan to do the fragmentation of each and units, packaging them out in such a way that their corresponding response back after receiving for every packet or fragmented packets, getting the response back is not immediately asked for. So, all the fragmented packets at a time they have combined, and one actually header file time period, HCS time they have added with it. Then the MAC subheaders and the MAC header, phi headers are there. So, the access time and the acknowledgement time across all the fragmented part they have clubbed together and then kept a small time to get the acknowledgement for all of them. It is not like that for each and every fragment, even if it is for the different users, you actually send and let me wait for the response time and all. So, that fragmentation helped them out to expedite. This is a typical beamforming process. suppose I have to now do the training and do the beamforming with you before the communication starts. I start from here. I know the total number of the beams that I am having. It may be the initial start process, or it may be the totally lost. The connection was totally lost. Both the situation, the transmitter beam starts the search. Okay. Once they could identify the location, the searching process is over. They do the beam forming. When the beam is formed, it means what? I first send you what is my location, my angle of receiver of receiving you, and then after receiving my signal, you measure the signal to interference noise ratio. You give me the feedback that hello, I am receiving actually this much amount of the SNR. I will slightly move over a grid, you will also move slightly over a grid, and by that actually trial and error methods, some point of the time we will be maximizing each and every point, we will be measuring our SINR, and what is the maximum SINR for my direction of departure of my rays and direction of arrival of that rays to your end, that will be jointly optimized, and some point we will be locking. Clear? So, how it will go? First initially I will do the omnidirectional and you will be scanning over, then he will be omnidirectional, I will be scanning over. So, like that we will try to find out first the sector wise. Suppose 360 degree I have first divided into 6 sectors. So, 360 by 6, 60 degree wise, suppose I will try to do the search. Out of the whole 60 degree, wherever the SINR is maximum, maybe for my sector number 2 and your sector number 6, the things are maximized. Okay. So, now we are getting aligned. Within this 60 degree, then I will be actually communicating over 60 degree, my beam width will be over 60 degree, and you have now refined the 60 degree another 10 divisions. So, you will move by 6 degree to find out within the 60 degree where the precious zone is. I will do the same thing for you.
So we are changing the beam width also.
No, you are first trying to find out the reducing the beam width.
So beam steering is.
Beam steering is going on. It is a typical beam steering. Sometimes we do not do it in practice with that all that painful structure. We have a codebook based beam steering mechanism. We based on the codebook, we will keep on switching the antenna array structures. Okay. No, actually there also there is a chance. If I know that you are here, why should I rotate my antenna? I should get the measurement, should get the news that the connection is off. Again the alignment will be done. Without knowing that you are off, why should I go for rotating? If I rotate, then the data communication is lost for most of the time, isn't it? So, this suppose this beam forming is done and transmit beam is acquired. If there is no channel variation, so that same acquiring situation will be staying. See, if this is a slow channel variation, then you need to go for the beam tracking also. So, at the end of the every packet, there is a time you should see what is the variation of the received SINR happened. Maybe I have started the transmission, I have started receiving the packet 5 minutes back, or maybe say 5 milliseconds, sorry, not 5 seconds, 5 milliseconds back. So, over the zone of the 5 milliseconds, I will be continuously measuring the RSSI values, received signal strength values, and I will keep on checking actually whether there is a decrement, huge decrement. If there is a decrement, definitely there is certain change in the channel happened. So, the bit error rate or the quality of the bit after decoder, if I am trying to continuously check in terms of the say bit error rate and the terms of the error I could compute. So, for every within a packet, for every segment wise, if I do that business, at the end by comparing over the every segment of those packets, I can easily compare and check whether there is a need of the beam tracking or not, channel condition has changed or not. If there is no dramatical change, I will be preferred to go with the ideal set or earlier set of the beamforming. Otherwise, you need to go ahead with the tracking immediately. The tracking means this, what you are saying. Okay. But if the beamforming tracking totally failed, then the beamforming acquisition is also failed, something whatever be the reason, you have to start with the beamforming procedure, full procedure once again. Start the sector search, do the sector search, Within the sector you now try to do the finement search, and then after finement, and for that everything you are exchanging the training information to do that. Once that is done, then again establish the link and start the data communication, otherwise do not do it. Okay. These are the typical usage scenarios for this 60 gigahertz 7 Gbps communication. Rapid upload download in broad sense, wireless display download, display and also the downloading operation, and WLAN connectivity also with your WPAN networks or the other sensor networks like the other communication cases. Only difference is that we have migrated in terms of the data rate by huge amount. This is a basic difference. 2.45 megahertz WLAN was here. Okay. We had the frequency hopping spectrum, IR devices, direct sequence spectrum, WaveDave, everything on the 2.45 gigahertz. On the top of that, today morning we have discussed about the distributed coordination beamforming, coordinating function, DCF function for the channel access. All the timing diagram that I was showing in the morning, that was in the base of the DCF, contention based, contention free, PCF, DCF we have discussed little bit, all were there in 2.45 gigahertz. Top of that there was a point coordinating function and your extended SCF contention access based function extension, SCF controlled access. So, all that was a max extension. By extending MAC in that way, they have enabled the 2.4 gigahertz, 5 gigahertz WLAN MAC to work and give the proper throughput. Where this 60 gigahertz is? Basic change is millimeter wave phi came into picture. What is the meaning of this millimeter wave phi now? How is it different from your 2.4? Millimeter wave phi means first distinct feature is the beamforming is there, which was never in the phi of your 2.45 gigs. WaveDM is still there. Directivity came into picture. So, lot of operation like your beamforming, training, tracking, those business are additive apart from your channel estimation, synchronization, everything. They are there. Top of that, these guys came up. So, millimeter wave channel access. How come it is different now the normal channel access? Where the question is whether DCF can straightforward work there. If I apply, answer is big no. DCF never considered that directional communication will go on. So, DCF never thought that for which direction I have to schedule my scheduler. Okay. No direction information at all was there till today in the MAC protocol development in any technology. Okay. Completely new approach is now required for the directional MAC design. Second important part, not only the directional MAC is going on, directional communication is there, MIMO will come in future on the top of that, cooperation will come because large MIMO virtual network will come into picture. Above all, everything should be done at a ultra low latency. Very fast session switching should over, very fast the network will be organizing them according to their wish. So, who will take care of this very fast message transfer, session transfer, and how we will devise on all that. Okay. There is a very good concept in the cellular network which was the frequency reuse. We understand, right? So nice that technology is. Here it is completely failed. So, how to use this frequency reuse now in the terms of your directivity? How will you do the spatial reuse in terms of directivity or in the presence of directivity? Okay. What will be the new devising mechanism for incorporating this, whether to go for frequency reuse or whether to go for the directivity, or how to combine the both and how to switch between the both. Okay. These are the questions came. Top of that, as the beamforming is a key enabler here, so the way the connection will be now setting up, point coordinating function, all the controlled access, everything got modified. So, the way the network will start operating, how the beacon will be transmitted, how a beacon can be transmitted if everybody is directional, everybody is sitting in his own domain. So, how to knock you, How to tell you that what is the condition of the network? Earlier we were transmitting beacon omnidirectional, people were sensing the signal, it was their task, they were extracting the information and they were sending the request. Now it is a task of the AP to first find your user, tell them hello, you get aligned, I will send you the beacon. Okay. So otherwise there is no way to make him listen, hello listen to me. So this is a fast task that AP should do, hello please listen to me. So how the protocol should start working, from that angle this whole structure got changed.
Why was directional introduced here?
Because actually your high frequency absorption is very high, you cannot go actually further distance. If you see the link budget with 60 gigahertz communication, you do the calculation, free space path loss calculation, you are off. Within 1 meter your whole communication is out. There is no budget to do the communication at all. This is a fundamental from the communication theory. You increase the center frequency of the communication and you put in the free space path loss equation, you are lost. No distance available.
And we couldn't
Frequency
leave the
reuse we did what way? We utilize that, we will sectorize in the cellular communication, we will utilize one frequency here and actually two users using the same frequency will provide the interference to each other. So what we did, we utilized the frequency, the same frequency, same channel we allocated for some other sectors who are really far from this zone. Okay, there is a calculation, typical calculation in the fundamental values where the same frequency can be reused. Okay, here we have a very huge bandwidth.
60-degree same frequency can be used.
Exactly. Even for the same sector, all the frequencies can be used because directivity is there.
So one reuse factor would be 1, that way you are saying.
I am saying actually sometimes it is the reuse factor will be 1, sometimes actually if I see that the alignment is getting disturbed, then the reuse factor should not be 1. So what to go and what should be the protocol to realize in the practice? Shall we go for the reuse or shall we don't go for the reuse? We don't know. Under what condition we will switch between reuse and directivity? Okay, clear? So MAC challenges. I have already talked about directional MAC, device discovery, very big pain. Means it's just as if actually it's my child, I have to search him for his own communication and then find him, tell him listen to me first and then actually tell hello this is your network, see actually these are all the typical features of your network, get listen to it and then be literate about all this and then actually you start your communication. Hello, are you there? You please get aligned with me, otherwise I cannot transmit you anything. So this is the situation. So even the downlink communication is going on, this pain is there with AP. Earlier this pain was with the users. Are you free? Please get me associated with, those kind of the requests used to come from the users. And AP according to the channel availability he used to allow them. And with the queuing and all the buffering and all the different users data and the traffic we used to schedule nicely. Situation is completely gone. Another thing is, so distributed coordinating function, which was really very good protocol for that MAC, WLAN MAC. Now we cannot actually utilize it here directly, that we have already used, and the special frequency reuse in face of the directional communication, how to go ahead with that, we need to revisit. Security, don't think at all that I have a very nice highly pointed directional communication, I don't need security. You need security very well there. So they came up with a different kind of the security protocol, which is called the Galvez counter mode protocol, to provide the security, link adaptation, power saving, addressing all in terms of the security, means aggregating them also as a part of the security. Multi-band support or the fast session transfer. Why they did it, you know? See, they are understood with the state of the art today's technology. I don't have the device, to transmit for 2 gigahertz. I have 7 gigahertz. Okay. So, what is my choice? At a time I can use only the 2 gigahertz. So, I should have the option of switching over multiple bands once again. Okay. So, fast session transfer over the multiple channels should be there. Also, aggregating the data over the multiple bands should be there. And who will do all that? The great Mac. He has to do it. Okay. So, multi-band, multi-channel switching, and that also very fast switching should be happening. Mac needs to devise all that. Directionality itself is a problem to Mac. Security on the top of that is a very big issue. How to provide the communication in the presence of blockage itself is a issue, and then this guy came that in order to have the usage of the whole 7 gigahertz, use switch man. Okay. Fast switch over the channel, very fast switch for the multiple bands. If I is switching and Mac is not supporting, then where the communication will go? Mac has to support that switching. And what will be the session transfer protocol to switch? Okay. In the MAC layer, if I have switched already, in the MAC layer you have to actually provide the bandwidth and the channel access, proper channel access for those fast switching. Clear? So, how to do that over the multiple user scenario? You are not doing for a single user, multiple users are doing the same thing continuously. How will you do that? So, then they came up with the concept of personal BSS. Morning we have heard about BSS, extended BSS, DS, distributed structure. These guys came up with on the top of that the personalized BSS. Personalized BSS is simple like the peer to peer kind of communication where they did for the infrastructure less BSS without any center. Then I told they came up with a group operator. Here this is the same concept. The PBSS is having a group operator kind of. That group operator alone actually can send the beacon, nobody else can send the beacon, and they will operate socially, and locally they will create a social network. This is the concept. See, you were asking, right, 60 gigahertz omnidirectional. This is the range you can go. You do the directional beamforming. So, the range automatically extends up to this. 5 gigahertz omni range is here. So, you can go even further with this 60 gigahertz beamforming. So, that is the point why we are here, and this device discovery is a pain to you for that. How the discovery goes on. This is one small example, the way standard gave you the solution. Standard told you let us keep a beacon time. Okay. In that beacon time, the access, so initially we will request everybody to actually stay in the omnidirectional mode. When you are not connected to a network, please be in the omnidirectional mode, but the AP will keep on switching over the sectors. Okay. So, he will keep on transmitting the beacons over the sectors. So, like that he is moving. So, he is having a beamforming, transmit beamforming, those guys are in the listening mode. So, they are in the omnidirectional. So, they have done it. But I didn't get your question.
The AP is transmitting to a station. What is the reverse thing? Station is transmitting.
I am coming. No, it is something like fast. You need to know where the beacons are. Okay. So, if you are trying to start your communication as a user, you have no other way. You have to just listen. The beacon transmission is very, means it's periodic. It's definite to come. Whenever there is a period for beacon transmission, he will do, but in the he will be doing in that sectorized mode. Okay. Why he is doing in the sectorized mode? Because if you are locating far from the AP, he will not be able to listen. So, he has to do in the sectorized highly beamformed mode. If you are having your antenna open in a omnidirectional zone, you will be able to listen. So, that listening is over by this BT period. This ABFT, the association beamforming training, when this is happening, then in this period AP will be in the omnidirectional mode. Okay. And whatever the you can now transmit with the highly beamformed. So, then this is again transmit beamforming, but beamforming is happening from the user side. So, now this is the task of the AP to segregate the received request from all the directions. You are orthogonal or the users are orthogonal in terms of the directions, nothing else is there. If two users from the same direction they send the request, there is another pain for AP to segregate these two. For that, file layer should have the capability and transmission technology to support you when two users from the same direction is trying to get associated, their beamforming strategy will be same. So, something should be there in the file layer to segregate their request coding, maybe the if it is spectrum based, the spreading codes, something you need to have different to keep orthogonalization between these two users, otherwise you are lost. Fine. Announcing the time and all, that is now the request response based. After hearing from those guys, now AP can understand who is where, in which direction. So, now he has to tell each and everybody what is the time period for the contention based transmission, what is the contention free period, what is the total time allowable for your transmission, for super frame size and all. So, if all that information needs to go, this will go here. Okay. And in the data transmission mode session, there is a contention based period and there is the service periods also. Contention based period, like the beginning in the morning we have discussed, everybody will fight for to get the channel, that will happen. And service period based means which is close to your contention free transmission, where the service based priority allocation will be there and you will be polled, your data will be polled by the AP during that period, that will go on. Okay, this is a description of the same. This is the concept of your fast session transfer. As I told, suppose station A is having 3 antenna. 2 of them are using the band 1 and band 2, 2 different bands and 2 different channels. Remember, I have the fast session transfer and communication is going on from here to here. Okay. Suppose there are 2 different kind of the fast session transfer. One is a transparent, another is a non-transparent. If it is a transparent session transfer going on, then the MAC IDs will be same, but when they are changing the bands, the MAC IDs both of them are using will be same. So, where is the commonality to identify that they are from the same users is seeing the MAC ID. They may be different in the channel or the bands, but the MAC ID for them will be easy. So, even if whenever they will be changing their band and if the MAC ID is getting changed, I will be able to understand according to the change of the MAC ID, both of the bands will be changing their channel. For both the channel, their MAC ID will be changed, but the same. But for the non-transparent fast session transfer, they are not only changing the bands, they are also changing the MAC ID. For non-transparent fast session transfer, it is really very hard to identify those sessions, and this option is there because you need the maximum flexibility. You need the maximum flexibility in terms of the choice of the channel, in terms of choice of the bandwidth, in terms of choice of the MAC protocols that you are going to utilize. If that is the situation, then your session transferring is a very big headache. You are using channel 1, channel 2. Next session, you are trying to use channel 2 and channel 3. Okay. So, I am changing the hopping concept that I was saying in ultra wideband, that concept was ultra wideband was not a big hit. The concept of this time frequency hopping for the high frequency high data rate communication and for the high frequency transmission, it was established that time. And these are all the extensions of all that, that fundamental concept of the how to utilize the multiple wideband channel frequencies by hopping and by aggregating, then actually changing where the change will be, how to integrate MAC on the top of that hopping, all that concept they have come up with in the 60 gigahertz. finally, I wish to end it here only because there are a lot of things to discuss. But here if I proceed towards the MAC, then it will break up the spirit of dividing the whole course concentrated in the Phi, MAC and the network zone. So, tomorrow morning giving the overview of the MAC, Professor GD will be leading you towards the deep in the MAC concept in this 5G zone. Tomorrow morning from here we will be first starting with the physical layer, more deep in the physical layer, understanding the channel conditions that have changed from for this ultra wideband to 60 gigahertz to millimeter wave whole zone, which needs to be very nicely understood, without which the devising the transmitter receiver modules is never feasible. If you do not understand our channel, we will be never be able to understand this kind of questions. It is really valid questions are coming up in your mind. I mean, why to go for the directivity, what was the problem of the omnidirectional cases, and how the channel behaves when I am increasing my frequency, what are the typical other problems that are coming up, why can't we directly integrate all the signal processing concepts and the MIMO, multi-user MIMO, LTPC code, STPC, everything jointly, put it everything there and then it will start working. It never happens. So, it has its own typical kind of problems. Let us first understand the wireless channel tomorrow morning, and then we will again revisit the physical layer issues dedicated for this millimeter wave communications in the next session. And then Professor GD will lead you towards MAC. Once Phi understanding is complete, he will go lead you deeper in the MAC. Okay.